Good morning to everyone.
Morning, ma'am.
Good morning, ma'am.
And now we are ready with the system and thing. Okay. Now let me introduce our guest faculty. Mr. Joji sir. Sir is in the pneumatic and hydraulic and electrical and also electronics. He is a field master in all the mechatronics field. He has written nearly some more than 45 books. He is the author of 45 books, and sir is also German trained, and he was in here with the JD post. Now he just last year he has retired. So please welcome our guest faculty. I'm happy to introduce that because of sir we are learned so many things. I was a student under sir. He has trained me very well, and he has set up our lab also, hydraulic, pneumatic and electrical and electronics lab. Please welcome our sir, and whatever you are having doubts, please share with us. Sir has more than 20 years experience in this field. So please welcome our Joji sir. We'll start the session with whatever the schedule, as per the schedule. So please, I'll welcome you, sir.
Thank you. Thank you.
So you can ask any type of questions related to your industry, whatever the working condition also. Okay.
Unmuted. No, sir. If there is any issue with the audio or video, please let us know, because the speaker is closer to the person who's speaking. So please cooperate. Wait a minute.
Okay. Good morning, dear participants.
Good morning, sir.
Good morning. Good morning. Yeah, welcome to the third day's program. Okay, so we are very happy to conduct courses for ONGCs. Okay, so I was working here in Formal Training Institute for quite long time. Okay, now I have retired. Okay, so during my tenure also, we used to train many ONGC participants. Many batches came. So even now, your batch also now would have been like to train you here at Bangalore. But anyway, because of this COVID issues and all, we are not able to directly train you. Okay, but we are training through online. So there will be associated with that. There will be some problems. Okay, so communication problem will be there. We are not seeing your face directly, so we are just speaking. Okay, but anyway, no problem. It is all to convey the technical information. So that is my aim. You can ask whatever doubts are there. Okay, and we will try to answer all your questions. Okay. I think today's class is about hydraulic pumps. Okay, so in the morning class, we'll in detail we'll talk about hydraulic pumps. Before that, just I thank Madam for introducing me first. So I would like to add a little more on that. Okay, so I worked more than 20 years in Formal Training Institute and in the labs of pneumatics and hydraulics here. So I used to I set up the new lab actually. So it was old system was there. So new trainer kits were purchased and it was upgraded later on during my tenure. So this all happened. So later on, now I retired from this organization. Now I started my own training center. Okay, that is called the Fluid Sys Training Center. Okay, so in the sidewise you can see the website details. You can visit these websites, and for some blog articles are also there. You can get so many information. Okay, and also I have written many books. So far, I think I have written 38 books. All these books are available in Amazon. The details are also available in jojibooks.com. Okay, there are also a lot of blog articles are there. The latest articles I am putting in the jojibooks.com. So a lot of information you can get through these articles. Anyway, we are coming back to our topic. Okay, today is hydraulic pumps. Okay, the hydraulic system, a hydraulic power transmission system is to transmit the power through the medium of incompressible fluid, that is oil. Okay, through oil now we have to transmit the power. Okay, so this hydraulic system is essentially an energy transmission, energy conversion systems. First time rotary mechanical force is converted to hydraulic power. Okay, there is a power source is required. Okay, so in that now we are using a hydraulic pump to convert the mechanical power input to hydraulic power. Okay, the hydraulic pump essentially create the flow in the system. So that is the main purpose of the hydraulic pump, to create the flow. Okay, later on the pressure also developed. Okay, whenever there is an opposition to the flow, there is a pressure development in the system. So the main function of the hydraulic pump is to create the flow. Okay, and there is a power pack, what we call it as power pack in hydraulic system. The power source is called a power pack because there are many other components involved in the hydraulic power source. Okay, not only pump. So there is a pump motor unit will be there. There is a pressure relief valve required. There is a tank required. In that there is oil also to be stored. Okay, and so nowadays the modern system is to have to construct the power source in or power pack as a modular system. In the modular system, so we'll have all tank is a module, pump is a module. There is a relief valve module. You have a directional control valves modules, throttle valve modules. All modules you can buy and you can assemble and you can make a system. Okay, excluding your actuator, cylinder or motor, remaining all can be configured as a module, as a system. Okay, using the components what are required, essentially required, you can purchase and you can assemble and you can create a power source. Plus your control system also in that. So that is how now the things are going on nowadays. Okay, but we are in the initial stage. We study individual component like pump. What is a pump? What is it is doing? What are the different types of pumps? What are the mathematics involved in the when you are dealing with the hydraulic pumps? Okay, lot of mathematical things. We are engineers. We should know what is the how you specify hydraulic pump. Okay, what are the relationships? Various input output relations are there. So those things I am going to take now today's class. Okay. So you can see the hydraulic pump. Okay, there is a hydraulic pump here. I think, are you able to see? So already it is there, no?
Yes, sir.
It's coming. Okay. So different types of pumps are there. Okay. There is also hydraulic system also given here. So there is a pump here. Okay. This is the subject matter for today's class. Okay. This is a pump. Okay. Pump is drawing the oil from a reservoir where there is oil here. Oil is stored here in the tank. Okay. And then it is drawn into the pump. When pump is driven by the prime mover, it will push the oil into the system. So in the system we have valves and cylinders. There is a direction control valve. There is a cylinder here. Okay. And there is a relief valve. Okay. You want to set the pressure in the system. Okay. That is through the relief valve. How you set the pressure in the hydraulic system? Okay. You can set the pressure in the hydraulic system by using the relief valve. Okay. Pump is not concerned with the pressure. Pump is concerned with the flow. How much flow it is giving. How much LPM, how much GPM. Okay, this is the pump is pump output is a flow. Okay, the pressure is developed when there is when you are pushing the oil into the system. Okay, the remaining part of the system is a closed system. Okay, system is closed. The oil will fill up. Afterwards, when the pump is continuously running, it is still pushing the oil. The oil will get squeezed. Okay, when the oil is getting squeezed, the pressure goes up. Okay, the pressure can go to a very high value instantaneously. Immediately, the pressure can develop to any high value. Okay, whether it is a 200 bar or 350 bar or 700 bar, whatever pressure, it can be developed. Okay, there is no problem in developing the pressure. The problem is all your components should withstand the pressure. So we have to restrict the pressure sometimes. Okay. So for that we are using the relief valve. You can set 200 bar means the pressure will not go more than 200 bar. When you set a 200 bar, in the system pressure will not go more than 200 bar. So relief valve is used to set the pressure. So pump will create 10 LPM or 20 LPM or 30 LPM. Okay. So that will be sometimes constant. Constant delivery will be there. Okay. So always it will deliver that much flow rate. That is the work of the pump to deliver the oil at certain flow rate. Okay. But the pressure is set by the relief valve. Okay. Pump is not directly connected with the development of pressure. Okay. It is also a party, but when it is pushing the oil and there is no space, oil gets squeezed, pressure goes high. That means when the flow encounters some difficulty, some opposition to the flow, there is a pressure development. Okay. When you pump the oil to open ground, then there is no pressure development. When there is a opposition to the flow, there is a pressure development. That is how the pressure is developed. But pump will have a pressure rating. So it has to withstand the pressure. Okay, say the 350 bar rating is there. Up to 350 bar you can set. Okay, that is the pressure it can withstand. Okay, that is the pressure rating. Like that, all components will have a pressure rating. In hydraulic system, pump or a relief valve or a direction control valve or a cylinder, all will have a pressure rating. Okay, but so what you set the pressure, that should be less than the pressure rating of all the components. Okay, so that is how regarding the pressure, I think you would have got a good idea about pressure and all last 2 days class. Okay, so but because these things are here in the system, I'm just telling. So here the pressure is set at 3000 psi. I know there is a unit of pressure is a PSI. Okay, one unit of pressure is PSI. Okay, this is in America, US, the US, US the PSI normally. In our country, we normally use bar. Okay, so bar is the unit of pressure we are using. Okay, so bar is equal to 1 bar equal to 10 to the power of 5 Pascal. So there is a pressure. So normally in hydraulic system, industry pressure is up to 350 bar. In industry, we are using pressure of up to 350 bar. Okay, there are systems which is working at 700 bar also. Okay, in hydraulic system, now there are some systems which is working at 700 bar. Okay, there are experimental systems which is working at 3500 bar. So in hydraulic system, there is a tendency to increase the pressure always. Okay. Approve something?
No, nothing.
Okay.
Yes, come here.
Okay. So now we'll see how the hydraulic pump, what is the working principle of hydraulic pump. Okay. So very, very simple system I have taken. Okay. There is one cylinder. You can see one cylinder. Okay. There is one piston here. Okay. The piston will move in and out. Okay. The piston will be pushed into the cylinder or bore, or it can be pulled out, pushed into or pulled out. Okay. You can have a prime mover. See, manually what is shown here. Later on, it will be replaced by an electric motor or an IC engine. Okay, that will drive the piston. Okay, so when the piston is driven, so it will move into it or it will be pulled out. Okay, so when it is pulled out, what will happen? Okay, you can see the other part of the system. There is a reservoir is there. Okay, in that there is oil. Okay, it is oil is kept in the tank. Okay. It is being acted upon by atmospheric pressure on one side. Atmospheric pressure is acting on one side of the oil. Okay. And then other side is coming to the barrel. Okay. The cylinder barrel, now inside it is coming. So when you are pulling out the piston, okay, there will be partial vacuum developed here. Okay. There is a space created here and there will be partial vacuum created here. Okay, and because there is atmospheric pressure acting on this other side, this oil will be drawn into the your cylinder barrel. So this space, oil will be drawn into it. So as the piston is pulled out, okay, oil will be drawn into the barrel. Okay, the valve V1 is opened. Okay, you can see one valve also kept. Okay, that is to contain the oil. Okay, when oil is drawn into that, it should not come back. So only it can go into the cylinder. So for that, one valve is kept, valve V1. So it will be opened and the oil will go into the cylinder barrel and it will fill up the space. Okay, when the piston is pulled back. Okay, when you are manually you are pulling back. Okay, so oil will be drawn into the cylinder or into the barrel here. Okay. Now in the second figure, you can see that we are pushing the piston into it. So at that time, valve V1 will be closed. Okay, whatever oil trapped here, oil collected here, okay, which is almost trapped. You are trapping the oil here. Okay, that trapped oil cannot go back. It can only go out. The valve V2 will be opened. It will be drawn out. It will be pulled out, ejected out. Okay, so the pump is creating the flow. You can see how the pump is creating the flow. First, in the first figure, the oil is drawn into the system. When you are pulling back the piston, oil is drawn into that. Okay, it is getting trapped inside. The oil is getting trapped inside. Okay, and then when you are pushing the piston into that oil cannot come back. There is a sealing. Okay, that oil is sealed, trapped and sealed. It cannot come back. And that oil has to be driven out. It will be ejected out. Okay. And it creates the flow. So take the oil from the tank, push it to your system. Okay. Delivered out. Okay. That is how the pumping action is taking place. even though this is a very simple system, okay, there are so many things you can observe here. Okay, one is the first thing is the drawing of the oil. In any pumping action, there is a drawing of oil. Oil is drawn into the system. Okay, then there is a trapping of the oil. Oil is trapped. Okay, then after that, what you find is the sealing of the oil. Okay, the trapped oil cannot go back to the your reservoir. It has to go to the system only. So it is sealed, and then it is delivered out, ejected out. Four things you are finding out here: drawing the oil, trapping the oil, then sealing the oil, then delivering the oil. Okay, there is one more thing that will come later on. Okay, that is the moving the oil. Okay, so there is a one more phase. Okay, so there are 5 things which we are going to see in any hydraulic pumping action. Okay, so in future now, whatever pumps we are going to see, okay, we will find the action. We will find the operation of the pump in terms of these 5 actions. How the oil is drawn into the system, how the oil is trapped into the system, how the oil is moving from one suction port to the discharge port, how the oil is being sealed, how the delivery is taking place. Okay, in all the pumps which we are going to see later on, okay, we will try to find out these 5 actions taking place. Then it will be very easy to understand the pumping action. Otherwise, you will think that there are many types of pumps. Okay, in all pumps, there is a pumping mechanism will be different, but these 5 actions will be taking place. So if you go like that, it will be easy to understand. Otherwise, you find one pump to the other pump, there is a lot of difference. You get confused. So to avoid that only, I am telling these 5 actions. So you can see that how the pumping action is taking place. You can very clearly, you can see here. Draw the oil, trap the oil, move the oil. Next. So, sorry for the delay. Okay, there is some technical problem. Okay, you can see the pumping action. Okay, the pump is moving in and out by when it's driven by the prime mover. Okay, it is moving in and out. How the pumping action is taking place, you can see here. Okay, this is a suction. Okay, taking place, and this is the discharge. So 5 actions are taking place. One is the drawing the oil, trapping the oil. Move is not there, but later on we will find this also. Seal and discharge. Okay, it's coming.
Yes, sir.
Okay. Okay. So having understood the basic idea of pumping action, okay, we'll elaborate later on. Okay, with the actual pump cross section we'll see, and we will study more in detail later on. Okay. Now we are going into the some mathematics. Okay, some of the parameters. How you specify the hydraulic pumps. So the first one is the volumetric displacement. Okay, VD, volumetric displacement. How much volume of oil now can be displaced by the pump in one revolution of its drive shaft. That is the volumetric displacement. It is the volume of fluid that is carried by the pump in one cycle of its drive shaft. It is normally expressed in terms of cc per revolution, meter cubed per revolution, liter per revolution, gallon per revolution, inch cubed per revolution. So like that, various units it can be specified. Normally in the industry standard, cc per revolution, or simply they will say cc. The pump is cc, how much cc, or how much inch cubed, cubic inch. So this is how we are specifying. Okay. In US, they say inch cubed, cubic inch. Okay. Rest of the world, cc is the normally used parameter or unit for volumetric displacement. Volumetric displacement is the size of the pump. What is the size of the pump? You can see a 0.8 cc means a small pump. A 10 cc means it will be a medium size pump. A 34 cc means larger pump. Okay, so cc represents the size of the pump. So that is a very important parameter for as far as the pump is concerned. Okay, whenever you are designing a hydraulic system, okay, so our ultimate aim is to find out the size of the pump. Okay, how much oil it can displace in one revolution of the drive shaft. Okay, so you are connecting the pump to a prime mover which is running at certain RPM. Okay, so you will get the flow rate. From that you can find out the flow rate. If you know the RPM, you can find the flow rate. So when it is manufactured, now you will not be knowing what will be the speed of the prime mover. So normally manufacturer will say the cc for the pump. So generally it is found out from the mathematics again, the geometry. Okay, when a pump is, say, suppose a gear type pump is there, from the internal geometry now we'll be able to find out what will be the VD. It is a theoretical value. VD is usually a theoretical value. Okay, so here now there is a gear now. Say there is a hollow cylinder when you imagine with a outer diameter DO and inner diameter DI. That hollow space inside that is represents the volumetric displacement in one revolution. Okay, so pi by 4 D output DO. DO means outer diameter square minus inner diameter square into the length of the pump. So that will be the volume of oil displaced in one revolution. So what I mean to say is, it is not by measuring. It is by determining by the equation. Mathematically, we are finding out the volumetric displacement. Usually, manufacturer will find the volumetric displacement from the mathematics, not by actually measuring it. That's why the flow rate, what you find out is called a theoretical flow rate. When you use VD itself is a theoretical value. Okay, so what you get the flow rate is a theoretical flow rate. Okay, so theoretical flow rate is given by the VD, the size of the pump, VD, volumetric displacement, into the speed. At what speed you are driving the pump? That is the N RPM. Okay, so VD into N will be the theoretical flow rate. Okay, why it is called theoretical? Because VD itself is a theoretical value. That's why it is called theoretical value. How much oil will be displaced by the pump or the suction side? From the suction side, how much oil is gone into the pump in one revolution? Okay, or in per minute or per second. Then you get the flow rate. So that also you can find out if you know the volumetric displacement. Another parameter is the pump slippage. Okay, so we say hydraulic pumps or hydraulic devices. No? Normally it is a positive displacement devices. So what do you mean by positive displacement? In positive displacement, what we mean is we are containing the oil very tightly. That means there is ideally zero leakage. When there is a zero leakage, okay, then we are able to contain the oil and we are able to utilize the oil fully for getting the work done. Okay, but practically speaking, there is always some leakage. Okay, there is 5% leakage or 10% or 15% leakage will be there. Okay, depending upon the how qualitatively you manufacture the pump. Okay, so accordingly the leakage will be there. So the leakage is called pump slippage. How much it will slip? Okay, so when you are drawing the oil and then you are discharging, okay, the complete oil is supposed to discharge, but some oil will come back. Okay, that is the QS. Okay, so we are giving QT. QT is equal VDN. It is going displaced by the pump. Okay, the entire QT is not going out. Some are leaking. Okay, that is called the pump slippage. It is a parameter. It is a function of the pump speed. Say more speed, more leakage, and the differential pressure across the pump. Okay, suppose 100 bar is there, you will get some slippage. 200 bar slippage will be more. Okay, so differential pressure across the pump and the condition of the inside surface of the pump. Okay, so the internal wear, that also matters, and the viscosity of the oil. Okay, very thin oil means the more leakage will be there. Okay, the viscosity less means thin oil, so the more leakage you will get. Thick oil means you will get less leakage. Okay, so this is a pump slippage. So very important parameter. Okay, in hydraulic system. Okay, we have to suppose we are designing system, we have to assume some leakage. Okay, we may assume 5% or we may assume 10% or we may assume 15%. Okay, depending upon the quality. Okay, so the slippage will be decided. Then the actual flow rate. What will be the actual flow rate? What you get? That is the theoretical flow rate minus the slippage. That is the actual flow rate which you get. Hydraulically, what you get for doing work, that is the QA. QA equal to QT minus QS. So that is the actual flow rate that is available for hydraulic work. Hydraulically, you get only QA. Okay. So so far what we studied is the parameters. That is the one is the VD, volumetric displacement, which is the size of the pump. Okay. And then from that you can find out, say when you are buying a pump, then you couple it to a drive motor, you know the speed. Okay, so VD into N will be the theoretical flow rate you get. Okay, and whatever the slippage is there, after that remaining you get the actual flow rate. That is how it is coming. See, one more thing, the actual flow rate will be it's a parameter. It's depending upon the pressure. Okay. The QA, what you get will be reduced. As the pressure increases, QA will be less because the leakage will be more. Okay, say this is a QT, the dotted line is a QT. Okay, but the QT will not get, the leakage will be there. As the pressure increases, leakage increases. The QA, what you get will be less. So QA will not be constant always. It depends on the pressure. Suppose you are using a 100 bar system. Okay. You set for 100 bar, you get some QA. But when you set for 200 bar, the same QA you will not get. There will be less. Okay. So now we'll see some other parameter. That is the torque. How much torque we are supplying to the motor. Okay. By the driver. Okay, the prime mover, which is giving the actual torque. So that is the actual torque delivered. That is the mechanical force, mechanical parameter. Okay, you are giving mechanical power and you are converting into hydraulic power. So mechanically you are giving the torque. Okay, the torque is actual torque. That is called actual torque. That is TA. TA can be found out from the, if you know the power, actual power if you know, and if you know the speed, okay, you can find out the torque. So there is one very good relation which you are, as a mechanical engineer, will be knowing that the power is equal to torque into speed. Okay, if the torque is in Newton meter and speed is in RPM, you have to use a multiplying factor. Okay, that is 1 by 9550. Okay, the power is equal to Tn by 9550. Probably you will be knowing this thing. Okay, so from that, torque we can find out. The torque is equal to actual power delivered by omega radians per second. See, another thing is P equal to T omega. Another relation is P equal to T omega, where omega is the speed in radians per second. Okay, if I am using torque as a Newton meter and speed as RPM, so this will be the better relation. Okay, so P equal to Tn by 9550. So that time we can use this equation. So the torque, actual torque, what we get in Newton meter will be equal to the pump input power in kilowatt. Okay, into 9550 divided by n RPM. Okay, so whatever may be the convenient equation, you can use it. Now we are also finding out the theoretical torque. Okay, in terms of the hydraulic parameter. See, once you give a mechanical power input, torque is given, speed is given. Okay, then your pump is being driven. Okay, then you get a flow. Okay, and there is a pressure development. Okay, there is a pressure development in the hydraulically. There is a pressure developed. Okay, there is a pressure P. So can we find out the torque in terms of hydraulic parameter? Because these are theoretically we are finding the torque. See, whatever torque you supplied, that will be going to the output. Okay, so mechanical torque, theoretically we find out, which will be equal to the what torque you supplied minus the friction losses. There will be some friction in the system. So after the friction, remaining will be coming as the torque. Okay, but actually there is no torque. Okay, so we are finding out in terms of the hydraulic parameter, that is equal to Vd into P by 2 pi. Okay, the theoretical torque is equal to Vd, the pump size Vd, and there is a pressure, okay, P, okay, divided by 2 pi. This is a theoretical value. Okay, this is not actual torque. Okay, so theoretical torque is also this is an important parameter. Okay, sometimes when you are designing the system, this equation will be used. Now there is input power. So what is the input power? So this is a hydraulic pump is there. Hydraulic pump. You are giving the torque and there is a speed. So these are the mechanical parameters available at the input of the pump. At the output, what you have? Pressure and the flow rate, PQ. Input you have got torque and the Newton. So what will be the input power? Kilowatt. In terms of kilowatt, it will be equal to TA, the torque, actual torque, into the n RPM divided by 9550. So this is the equation, governing equation for the input power at the hydraulic pump input. At the input of the pump, this is the power delivered. Okay, TAN by 9550. What about the output power? What are output parameters? The hydraulic side. So you have hydraulic power now. So that is pressure is there. There is a flow rate Q. So output power will be equal to PQ by in kilowatt I am telling. Okay, so P into Q. Okay, P is in Pascal, QA in meter cubed per second. Divide by 1000 will give you the kilowatt. The power in kilowatt will be equal to PQ by 1000. Where P is in Pascal, Q is in meter cubed per second. But normally we use bar and LPM. Okay, so in industry also when you go, we are not using Pascal or we are not using meter cubed per second. We generally use bar and the LPM. So in terms of bar and LPM, the power in kilowatt will be equal to P into QA by 600. So this is the most convenient equation. Okay, PQ by 600, where P is in bar, QA in LPM. So you can remember this equation. Input power will be PQ by, torque into Newton by 9550. So these two equations, if you remember, so many calculations you can do. Okay. Now we see some of the efficiency terms for hydraulic pumps. So hydraulic pump now, say you are giving a QT, input drawn by the oil drawn by the pump is QT, and what is the oil going out after the slippage, what is coming out is QA. So what will be the volumetric efficiency? Volumetric efficiency will be equal to actual flow rate QA divided by the theoretical flow rate. That is the volumetric efficiency of the pump. Okay, so volumetric efficiency indicates the extent of leakage in a frictionless pump. So that is the volumetric efficiency of the pump. Similarly, mechanical efficiency is there. Okay, you are giving the torque TA, and you get TT as the output, theoretical torque. Okay, as the output after the frictional losses are taking place. So you can say the mechanical efficiency is equal to TT by TA, output torque by input torque. That is the output torque by input torque. That is the mechanical efficiency. Okay. Otherwise, you can say in terms of the output power, when there is no leakage, what will be the output power? Say PQA I have to use. When there is no leakage, QA will be equal to QT. So PQT by what is the input power? TA into N. When there is no leakage, okay. So what is the output power by input power? That also represents the mechanical losses or mechanical efficiency. Okay. So that way also we can find out the mechanical efficiency. Otherwise, if you know the torques, TT by TT and TA, this ratio will give you the mechanical efficiency. So mechanical efficiency indicates the extent of frictional losses in a leak-free pump. Okay. Then we have the overall efficiency. Overall efficiency is equal to output power, PQA, total output power what you get, divided by what input power you are giving. That is the overall efficiency of the pump, which can be also found out from the volumetric efficiency into mechanical efficiency. Okay. Suppose volumetric efficiency is equal to 0.9, okay, 90%, 0.9, and mechanical efficiency also 0.9. So overall efficiency will be 0.9 into 0.9, which is equal to 0.81. Okay. So that way overall efficiency can be found out. Okay. So these are all the relations. Okay. The complete the summary of the relations what we have studied. Okay. Which we are in relation to the pump, which is here. So pump is here. The symbol of pump. So parameter of pump is equal to VD, where you are giving you are connecting to an electric motor, which is driving at a speed of N and which is giving a torque of TA. Okay. There is a leakage, there is a friction. Okay. So what will be the QT? QT will be equal to VD into N. Okay. VD into N will be the QT. After slippage, you get the QA. QA will be equal to QT minus QS. So at the output, you have got the QA. Okay. So we'll find out the torque. Okay. What is the input power or torque? Input power, you can say input power is equal to torque into N RPM divided by 9550 in kilowatt. The power input will be much. Power output will be P into QA by 600 LPM kilowatt, where P in bar, QA in LPM. Okay. So whatever the entire relations, what we learned so far, which is here in one figure. In this slide, all complete relations are here. Even efficiencies are there. Mechanical efficiency TT by TA, volumetric efficiency equal to QA by QT. The overall efficiency equal to P output by P input. So all these relations are here. So this will be important when you are designing the system or when you are specifying some of the parameters. So when you are buying the pump, some parameters you have to specify. You should understand the meaning of the parameters. So for that, these relations are very important. Okay. So these are the total relations. Okay, in the hydraulic pump. So if you know this one, it will be easy to handle the pump. We'll break.
Break, sir.
Huh?
Okay.
You want break or
Break,
can
sir.
continue?
Yeah, we'll give a break.
Okay. Okay, now we'll give some 5 minutes break. Okay. After that, we'll start again.
10 minutes.
10 minutes break we'll have. Then after that, we'll say the classification of the pump and we'll have the construction of the pumps. Okay. Different types of pumps we'll learn. Okay. Just 5 minutes break. 5 or 10 minutes break.
10 minutes.
Okay. You can manage that.
We'll manage that.
Hello? Hello?
Hello, sir.
Sir, there is a disturbance. Hello, is it audible now? Can you please respond?
It is also audible, sir.
Okay.
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 Okay. So now we'll start the classification of pumps. Okay, hydraulic pumps are classified into a positive displacement pump. Okay,
Your PPT is not.
PPT not displayed.
Okay. Thank you, ma. Please respond like that. Otherwise, will not come to know the thing.
Is it visible now?
No.
No, sir.
Yes, sir. Yes, sir.
Please check once more, please. Please check once more.
Classification of pumps is visible.
Okay.
That one.
Okay, thank you.
Okay. So pumps are classified into non-positive displacement pumps and positive displacement pumps. Hydraulic pumps are always a positive displacement. Okay, we are not using dynamic displacement pumps in hydraulic system. Out of the positive displacement pumps, we have got fixed displacement, we have got variable displacement. Okay, so when the displacement is fixed by the construction, now if the displacement is fixed, it cannot vary, then it is a fixed displacement. In the fixed displacement, we have got gear type, vane type, and piston type pumps. Gear type, again, we have got external gear pump, internal gear pumps, gerotor pumps, screw pumps. Okay. In the variable displacement, we have got only vane pump and piston pump only. Only vane pump and piston pumps can be variable displacement. We'll see the constructional details slowly. These are the pump symbols. Okay, this is a pump. Okay, this is a fixed displacement pump, unidirectional, only one direction. Okay, this is a variable displacement. When a variable displacement is there, you will give an arrow mark. This is a variable displacement. This is a unidirection. Okay, normally industrial hydraulics, pumps are always unidirectional. You'll have a reservoir and always the oil will be going to one direction only. Okay, so that is how this type of pumps are used for industrial hydraulics. We have got also mobile hydraulics. The mobile hydraulics, outside. So mobile systems, the excavators or bulldozers, all these are mobile systems. Okay, or even aircraft or even your ship. Okay, so these type of systems will have a bidirectional pumps. Okay, so what is known as hydrostatic transmission. These type of systems are used in those type of systems. Okay, so there the bidirectional pumps are required. So that symbol will be like this. This is a bidirectional pump. The pump can discharge on both directions. So bidirectional pump and a variable displacement also possible in that case. So industry is, as far as industry is concerned, we are only using unidirectional pumps. And one more thing, that is the motor symbol. Okay, what is the difference between motor, hydraulic motor and hydraulic pump? So pump will be always delivering the oil. Okay, it is the delivering the oil. Whereas motor will be sinking the oil into the motor. So the symbol will be like this for motor. They are able to see, no? Motor. This side,
Yes,
one end.
they can see.
Okay. So that you should understand when you are Ongc, when you are taking the drawing. So they will not write pump or motor and all that. So by symbol you must be able to understand. So this is a symbol for the pump. This is a symbol.
Then there is a disturbance. Sir. Then there is a disturbance. No, sir, it is not. Sir.
Also, it's not audible yet.
How about now? Is it audible clearly? Please respond.
Yes, sir.
Okay. Okay. So now we'll see the construction of pumps. Okay, so first one is a gear pump. Okay, in the gear pumps, there are various types. First is the external gear pump. Next one is the internal gear pump, gerotor pump, screw pump. Okay, we'll see the construction. Okay, you can see the gear pump. Okay, so this is an external gear pump. The external gear pump. Okay, so there are two or more gears, that will be intermeshing. Okay, so one of the gears will be driven by the prime mover. Anyone can be driven by the prime mover. Other will be carried by the first one. Okay, so one is the drive one, other is a driven one. Okay, so these are enclosed in a housing, tight fitting housing will be there. Okay, there will be very minuscule clearance here, maybe some 10 micron or 25 micron. Okay, so that much clearance only will be there between the casing, this is a casing, internal casing, and the gears. Okay, so when these gears are rotating, say when it is driven by the prime mover, so one will be rotating in one direction. One say this is a clockwise, this will be anti-clockwise. So in different direction it will be rotating. You can see that. Okay, at the center now it is meshing. This part it is the tight sealing will be there. Okay, between this is a suction side, this is a discharge side. So here now you can see the volume is increasing here. Is developing the volume. Space is created here. Okay, therefore there will be partial vacuum here. Okay, due to partial vacuum, the oil will be drawn into the pump. So oil is drawn into the pump, and it will be trapped in the chambers. The fluid chambers are formed between the cups. So cup is there and the casing is there, and the side plates are there. Okay, along the lengthwise, there will be fluid chambers formed. So now, see both sides, fluid will be trapped. This side and this side also. The fluid will be trapped. That fluid will be moving from the suction port to the discharge port. It is moving toward the discharge port. You can see here the animation. So it is moving toward the. So here it is. When it comes here, so it has got two ways. Either it can come back or it has to go out. As there is a tight sealing here, this oil cannot come back. Okay, and because this is driven, that force, because of the force, it will be ejected out. Okay, so earlier I was telling, there will be a drawing of the oil, trapping of the oil, moving of the oil, and there is a sealing, and there is a delivery. All the 5 actions you can see here. Okay, if you look at that angle, it will be easy to understand the working of the gear pump. This is external gear pump. Okay, so there will be drawing of the oil, trapping of the oil, and the oil from the suction side to the discharge side, it has to move. Okay, so because of the rotation, it is moving. Okay, and that force is imparted to the oil, and it is pushed out. Because the sealing, it cannot go back. Okay, if there is a easy way to go back, it would have gone back. Because of the construction, there is a tight sealing here. Okay, the oil will be ejected out. This is a pumping action taking place in the external gear pump. As it is used for many months or many years, there will be wear. At that time, the leakage will increase. Okay, so more leakage will be there when the more wear is taking place. When more wear is taking place, more leakage will be there. The loss of fluid will be there. Okay, we are not able to utilize the energy properly at that time. Okay, this is an external gear pump. So gear, that will be spur gear, there is helical gear, and there is a herringbone gear. See how the gears are designed, accordingly the thing. See, normally what happened, see, so these are pushing the oil, one volume of oil is pushed out, then another volume is coming, it is pushed out. Okay, in a pulsed way, the oil is going out. Okay, there is a pulsation. Say one pulse it is going, after that next pulse is coming, after that next pulse is going. So in the spur gear, the pulse will be more pulsation will be there in the discharge of the oil. Okay, we want to reduce the pulsation. That's why we make a little angle, so that see suppose this is a discharge port is here. Okay, so 2-3 chambers will be open to the discharge port. So you get less pulsation. Okay, in that case. Okay, but the problem here in the helical gear is that, see, one side oil will be more, Okay, the side load on one side will be more. One side weight will be more. Okay, to cover that, we use a herringbone. Okay, we make a helical two angle we make, and therefore now when this is there, both side oil will be same. Okay, it is more balanced. Okay, you will get a steadier discharge, less pulsation. Okay, and the side load effect will be reduced. Okay, so this type of herringbones can be used. So this is a gear type designs. So this is a spur gear. This is a helical gear.
Where I speak.
Yeah, please.
Any doubts? Hello? Is it audible?
Yes, ma'am.
Yes, ma'am.
Okay.
Okay.
So now we'll go for the see this as far as parameter. Now we already studied the main parameter is the displacement, cc, cubic centimeter per revolution. So that is the 1.1. Okay, 1.1 is the cc, 1.1 cc per revolution. Okay, so normally this pressure rating will be given. So 210 bar is a continuous pressure. Okay, see sometimes the pump has to withstand the intermittent shock pressures. Little high pressure may come for a short duration of time. Okay, so it can withstand up to say maybe as per the specification 250 bar it can withstand. Okay, so that is the maximum intermittent pressure. Okay, maximum continuous. Suppose your machine is working continuously, maximum 210 bar you can set. So that is the meaning. Yeah? So you have to set the pressure less than 210 bar for this pump. Okay, maximum speed of rotation is 6000 rpm, and minimum rotation should be 600 rpm. Okay, so now sometimes manufacturer will give the flow rate. Okay, at they have to specify the watt speed. Okay, flow rate is a VD into say VD into N. We already studied it. Okay, so 1.1 is the one sample calculation I made here. See, 1.1 is the displacement. 1.1 is the cc, cubic centimeter, into what is the speed? 1500 rpm. Okay, so cc to liter it is I divided by 1000. Okay, see 1 liter is equal to 1000 cc. So that's why divided by 1000, you get 1.65 lpm. So that's why it is 1.6 is coming here. Okay, so you can calculate for others also. Okay, so this value you can not required actually, but we can calculate. But manufacturer has given, so we can directly refer to this value and we can select. This is not required. This is internal gear pump. Okay, so here again there are two gears. Okay, this is a gear within the gear. So one gear is there, outer gear, and there is an internal spur gear. Okay, and outer gear. Okay, so this gears, any one gear can be rotated by the prime mover. Other gear will be carried by that one, that force. So both will rotate. Both will rotate in the same direction. In the external gear, now both gears were rotating in the opposite direction. Here both will be rotating in the same direction. Okay, and these gears are arranged in a not a concentric. Okay, there is an offset. Internal gear, internal spur gear, internal rotor gear, which is at one side. You can see there is an eccentricity between the internal gear and the outer external gear. Okay, outer gear and internal gear, there is a gap here. Okay, actually that gap is closed by a crescent shaped spacer. One spacer is kept here, which is not moving, which is constant. It is not moving, stationary, which is stationary. Okay, so now see when the gear is rotated, okay, there is a space increasing here. Okay, at the inlet port, the space is increasing. There is a partial vacuum created here. Okay, where partial vacuum is created, oil is drawn into the pump. Oil is drawn into the pump. Okay, and then it is carried here. When it comes to the crescent shape spacer, okay, both sides oil will be trapped. Here also oil will be trapped. So oil is transported from the suction side port to the discharge port. Okay, so oil is trapped, oil is moving, and then there is a tight sealing here. Oil cannot go back. Okay, and oil will be pushed out now because of that trapping. Okay, and there is no space to go out, go back to the system. The oil will be pushed out to the discharge through the discharge port. It is pushed out. Okay, so here also you can see the 5 actions. Okay, one is the drawing of the oil, then trapping of the oil, moving of the oil, sealing of the oil, and then there is a discharge. All 5 processes or pumping action, okay, all 5 processes in the pumping action is taking place here also. So it is easy to understand, but the mechanism used is different. Okay, we are using internal gears. Okay, a gear within the gear is used, and there is a gap in that. Okay, through that we are trying to pump the oil. Okay, trap the oil and push the oil. Okay, and it will be carried through the pump, and it will go to the discharge side. Okay, but even though this is a very complicated design, actually this is a complicated design. Okay, but the noise produced is less. Okay, compared to the gear, external gear. Okay, so this pump also there. It's called the internal gear pump. You can see the one more animation. So this is the internal gear pump. Oil is drawn and it is trapped, and then it is sealed, then it is pushed out. It is moving and it is pushed out. See, these are parameters are given. Okay, the displacement is cubic centimeter per revolution. So that is a 3, 4, maximum 125 cc size is given here. Okay, shaft speed is given. These are the parameters normally manufacturer will give. What is the constant pressure or the peak pressure? These are shock pressure and all. Okay, so normally if it is a continuous operation is involved, we use this value 315 bar. Okay, so the torque is the electric motor. This is the electric motor torque, and the kilowatt is given here. Okay. This is a generator pump. This is like internal gear pump only. This is like internal gear also like this only. There was a gap was there that is closed now. Okay. By properly profiling now, you can close the gap. Okay. So here again 2 outer gear and internal rotor gear. Okay. So that will be always the tip of the internal gear always touching the inner gear. The outer gear, no? Inner surface of the outer gear always is in contact. Okay, the gap will not be there. Then the leakage will be there. Okay, so now when this is rotated, any one gear is rotated, both will rotate together. Okay, in one direction it will rotate. So here the suction side, the volume is increasing. So oil is drawn in, and then it is trapped. Oil is trapped, and then the trapped oil is pushed out. Okay, because there is tight sealing here, it cannot go back. Okay, so by the force of the electric motor, that oil will be pushed out. Okay, so here again you will see the 5 actions: drawing the oil, okay, trapping the oil, moving the oil, sealing the oil, and then ejecting the oil. All 5 actions are taking place here also. This is called generator pump. Okay, the components used are less, very simple pump. Okay, but we cannot use for high pressure or high flow rate. We cannot use. This can be used for some applications in hydraulic system. Like in the mobile system, charge pump. As a charge pump, this can be used. It cannot be high power or high pressure system. You cannot use. These characteristics are also given. Now the screw pump. Okay, so you can have screws, single screw or 2 screw or 3 screws, multiple screws you can use. Okay, so when any one screw is rotated, the other screws will also rotate along with that. So here the oil is moving actually through the space created here. Okay, and then it is moving actually, and it will go to the discharge port. This is a screw pump. Okay, so here again the suction is taking place. Okay, it is trapping the oil, moving the oil, and then it is ejecting the oil out. Okay, this is a screw pump. The screws may not touch each other. There may be a small gap between one screw to the other screw. There is a gap is there. Okay, you'll have a timing gear. Only that will be in contact. That will that will contact and it will rotate both. But actual pumping action taking place in these screws, that will not be in contact. There is a little gap will be there. Maybe say 5 micron gap or a 10 micron gap will be there. The oil will not leak, so oil will be trapped and oil will be moving. Because of that, the noise produced by the screw pumps is less. The lowest noise producing pump is a screw pump. Maybe 60 dB decibels, 60 decibels, okay, or to that extent the noise will be there in the screw pump. All other pumps, the noise will be more, okay, like vane pump or piston pumps, maybe 85 or 80 dB. The other pumps, the noise will be more. So in application, we want a low noise, we can use a screw pump. So like hospital application, okay, we don't want a large noise. So such applications you can use this type of pumps. Then we have got the vane pump. Okay, this is an unbalanced vane pump. Okay, here now there is a rotor which is being driven by the prime mover. Okay, and in the rotor now there is a radial slots. There will be slots. In that slots now you are fitting the vanes. Okay, you are arranging the vanes in the radial slots. Okay, so the vanes can move in and out. There you can see the vanes are moving in and out. So it is coming in and then it is moving outward. Always when because of the rotation, the vanes are moving outward. Okay. Sometimes backward, there will be a pressure given or a spring will be provided. So the vanes will be moving outward. Okay, and always it will be in touch with the cavity. Okay, here there is a little mistake is there. Okay, it is moving still out of that. So it will be maximum moving to the cavity. Okay, so it will be moving. Okay, let us see the pumping action, how the pumping action is taking place. The rotor is driven by the prime mover. Okay, the vanes are moving now. So there is a increasing space at the suction port. At the suction port, where the suction port is coming, the space is increasing, partial vacuum is created, and volume of the oil is drawn into the pump. And then there is a trapping of the oil. Oil is trapped here in this space. Oil is trapped between the two successive vanes. Oil will be trapped. Okay, so that oil is now moving, and then okay, it is sealed. Okay, therefore it is discharged out because the vane now pushing it out, and you get the output. Okay, oil will be coming out. So there is a drawing of the oil, there is a trapping of the oil, moving of the oil, sealing of the oil, and there is a discharge. Okay, these 5 pumping actions are taking place here also. But the pumping action is because of the vanes. You are arranging the vanes. Okay, the vanes are creating the space and trapping the oil and okay, moving the oil and discharging the oil. All these are done by the vanes. That's why it is called vane pump. But you can see that why it is called unbalanced vane pump, because there is a one side, see the shaft, when you see the drive shaft, one side the weight will be more. Therefore, the side load will be more on one side. That's why it's called unbalanced vane pump. Okay, so you should have strong bearing required, because see here the pressure also will be there. That pressure is acting towards one side. So this vane pump is called unbalanced vane pump. Okay. So life will be reduced, because of the unbalanced vane pump, his life will be reduced. Okay, you have to frequently you have to replace the bearings and all. Okay, so these are the problems. The same thing.
Why do we use vane pumps?
Vane pumps, say because this also like screw pump, low noise producing pump. Okay, vane pumps low noise producing, because these are elastomeric material. The vanes are elastomeric material. So which is rubbing, the noise will be less. Okay, so where the noise, less noise only required in application, you can use a vane pump also. Okay, you can use a screw pump. Okay, or you can use a vane pump. Okay, so the first criteria is whether noise is whether less noise is required in application. You think of a screw pump. Okay, screw pump, that much power is you are not getting. You go for the vane pump. Okay, so vane pump can be used at that time. Okay, now see that is the problem with unbalanced vane pump. Now the side load now will be more. The side loads will be more. So you want to make it a balanced. So you can have you can change the design. Okay, you can have a cavity. That cavity is a larger oval shaped cavity you can make. Okay, in that there is a circular rotor where the your veins are in the circular rotor. Okay, so circular rotor is arranged in a larger cavity, oval shaped cavity. Okay, if you arrange like this, you'll have two pumping chambers. One pumping chamber is here. So your suction is coming here, inlet. Okay, inlet is coming here. Okay, the space is created here. Oil is trapped here. Oil is moving here. Oil can be ejected out and it can go out. Similarly, you direct the oil toward this side also. Okay, so then here also again when it is rotated in one direction, this is a suction port. Okay, oil can be trapped. Okay, because of the partial vacuum here, and then it is moving to the discharge port and it can be discharged out. But any angle if you take, it is balanced. Okay, that's why it's called balanced vane pump. Okay, so this is a
Okay.
so this is a design of the balanced vane pump. Okay. So here again you can see the inch cubed cc per revolution, 22.8 cc per revolution you can get here. Okay. And the pressure will be maximum pressure up to 175 to 1440. Okay. So pressure rating of the pumps are concerned. So you can say gear pumps and vane pumps can be up to you can say 275 bar. Okay, 275 bar we can use gear pumps and vane pumps. Okay, but typically we may use up to 210 bar only. Even though some manufacturer offer 275, sometimes even 310 bar. Okay, some manufacturer will offer, but generally speaking, we can use up to 210 bar. Okay, external gear pumps can be used up to 210 bar. Okay, sometimes internal gear pump can be in a very generalized way. If I speak, I can say 175 bar only we can use. Okay, in a very, but the technology is improving. Manufacturers are offering more and more pressure ratings. Okay, so they are improving the design. So future it may change. So very typically speaking, gear pump can be up to 210 bar. External gear pump, internal gear pump can be up to 175 bar. Okay, maximum I'm saying maximum. So it can be less than that only. Okay, vane pump also to that extent only we can use. Only very high pressure required, you have to go for piston pumps. Suppose 350 bar or 700 bar. So like that pressure is required, you have to go for piston pumps. You cannot use vane pumps and gear pumps at that time. Now we are coming to the piston pumps. See, this already we have seen. See, one piston moving in and out, the pumping action can be created. Okay, the pumping action is developed. Pump creates the flow. It draws the oil and pushes the oil out. So this pumping action is created by one pump. Okay. So when you see when it is drawing the oil, there is no discharge. When the pump is drawing the oil, there is no discharge. Okay. When it is discharging, there is no drawing of the oil. Okay. So one half you are getting the discharge, one half there is no discharge. Okay. Again, one half it is coming. Okay. So you are not getting continuous flow. Okay. Pulsation, and that also half of the period there is no flow also. Okay. So this may not be very efficient way of pumping. So can we use one more pump? Okay. So one is drawing, the same time one is drawing out. So that way we can design, say like this. If you arrange two pumps, okay. So this two pumps can be arranged, okay, in a circular way we can arrange, okay. So that is being rotated by the prime mover. So when one is, okay, so this is a suction, this is a discharge, okay. So when one cylinder is sucking the oil, other will be discharging. Now this start sucking the oil, okay, and then it is moving to the discharge side. Now start discharging, okay. So this way if you arrange two pistons, two cylinders, okay, you can get much more, you can get more output, more discharge, okay. Still if you arrange more, still more if you arrange, the number of pistons are more arranged, okay, you get more output and less pulsation. Okay, so this way only we are arranging. Okay, so this is a piston pump. Okay, not one cylinder. We are not using only one cylinder. We use number of cylinders. Okay, which is arranged. You can arrange the pistons either axially or either radially. Okay, you can arrange axially. You can arrange. Okay, say here now the one piston. If you think one piston and the other piston both are in parallel, and it is arranged in axial way. So in the cylinder block, there is a cylinder block. The axis is all the cylinders are parallel to the axis of the cylinder block. So that way you can arrange. Okay, no doubt you can arrange radially also. Then it is called a radial piston pump. This is an axial piston pump. Okay, all the pistons are arranged axially. Okay, and then there is what are other things you can find here? There is a cam plate. Okay, so the pistons are fitted to the cam plate in the shoe. Okay, the ball here arranged in the inside the shoe. So it is fitted like that. Okay, and then the piston will move in and out. So here the blue color when you see, it is increasing the volume there. It is drawing the oil. When it is rotated by 180 degrees, it starts discharging. The volume is reducing. Okay, that is because of the cam plate. If the angle is maximum drawing of the oil will be there, maximum output you will get. Discharge will be maximum, delivery will be maximum when the angle is maximum. Okay, if you arrange the angle, you change the angle, you change and you make it to 180 degrees. Sorry, okay, so perpendicular. So this cam plate, you arrange perpendicular to the drive shaft. Okay, then you see that the piston will not be pushing in and out. It will be simply stationary and it will be just rolling. So there will not be any pumping action. When the cam angle is less, the pumping will be less. The output will be less. Okay. So you can make it a variable displacement here. A piston pump can be made variable displacement by changing the cam plate angle. Okay. So you'll have a cam plate will be there or a sash plate. It is called actually sash plate. Swash plate. Okay. So that so with that arrangement, the pumping action is taking place. This is the drive shaft. Okay. It is connected to the drive, electric motor or IC engine. It is connected. So it is driving the cylinder block. The entire cylinder block is rotating. Okay. This is a valve plate. Your valve block is arranged. This is called the suction port and discharge port arranged in the valve plate, which is stationary. Okay. So here the cylinder, the cylinders are moving, in contact with either the suction port or the discharge port. So that way it is there. So here you can see 3 cylinders are sucking the oil and 3 cylinders are discharging the oil at different stages of pumping. Okay, one will be just started sucking or drawing the oil. Some will be middle, some will be in the completely. It is volume is created and the complete oil will be drawn inside. After that, you start pushing the oil through the discharge port. Coming.
This is sharing or that is it? Okay, sir.
Fine.
Okay, na? So this is an inline piston pump. Okay, this is a cam. This is a cam actually. This is a cam arranged. So because of that, the pistons are moving in and out. The pumping action can take place. Okay, maximum this much. This is a fixed displacement. We cannot change the angle here. Earlier one, you can change the angle. Suppose variable displacement, how it can be made. Some difference is there.
Some lag will be there, sir.
Yes.
That lag will be there.
I'm not able to get one figure.
No problem, sir. There is a lag.
Okay. So So one figure I'm not getting here, okay, but you can just visualize, okay, this angle when you change, okay, by external means, by manually or even hydraulically also we can change. There will be one cylinder which is moving the cam plate angle, okay, the delivery, can be made variable. So the piston pumps can be variable displacement also. So again, this parameters you can see, okay, this is a cc per revolution, 63 cc per revolution, okay. Then this rated pressure is 350 bar. Higher pressure can be obtained through piston pumps, and peak pressure is 400 bar. Torque, there is electric motor torque is this much. The rotation speed is 2600 rpm. Okay, maximum boosted speed is 2250 rpm. This is a bend axis piston pumps. Okay, so there is also bend axis piston pump. This is a cylinder block. This is a drive shaft. Okay, there is an angle. Okay, so when this is rotated, so the piston here will move in and out. Okay, so like that. Say it will move in and out. Is drawing the oil, more oil will be drawn here. This will be pushed out. So the piston will be moving in and out. The pumping action can take place. Okay. Here the side load effect will be less. Okay. Say the cam plate angle also you can change and you can make the angle. Okay. So that how it is fitted. By the cylinder block is fitted to the drive shaft. That is the difference here. Actual difference is that one. Otherwise, the basic principle is same only. Okay, how the pumping action taking place? The basic action is same only. The difference is the cam plate. That the side load effect will be more. See here, it is fitted. The piston is fitted to the cam plate angle through the shoes here. Okay, but there is some other mechanism. It is fitted in the bend axis piston pump. That's why the side load effect will be reduced here. The side load effect will be reduced. Okay. So sometimes some applications this will be used. Okay. It is bulky. The problem is it is very large in size. This is a radial piston pump. Okay, radial piston pumps. Your cylinder and the cylinder block, this is arranged radially. Okay, this is a cylinder block. Okay, so which is being rotated by the prime mover. Okay, and this piston is moving in and out. Okay, like a vane pump. See, in the vane pump, we are trapping the oil here, in between the vanes. But here the oil is trapped inside the barrel. Okay, that is the difference. Okay, so here the suction side, it is port is here, and discharge port is arranged with the center side. Okay, there is a spindle. Okay, there is a suction port. So here you can see the volume is increasing. Oil is drawn inside. And then it comes to the discharge. When it is coming in this area, which is connecting to the discharge port. So oil is moving out through the discharge port. Okay. So here the oil is being drawn into the suction port. Okay. It is moving, trapped, moving, and then it is coming to the discharge port. It is coming out. Okay. A flow is created here. Okay. This is how the radial piston pump is working. Okay. So the cylinders are arranged radially. Okay. As far as the characteristics are concerned, this is the highest pressure development possible in this pump. Suppose you want a 600 bar, 700 bar, you can only use radial piston pumps. Okay. Axial piston pumps can be used up to 450 bar. Up to 450 bar design is available. Okay, for axial piston pump. Now, suppose you are using 600 bar, 700 bar, only radial piston pumps can be used. Okay, this is a high pressure, high power pump in hydraulic side. Okay, that is a radial piston pump. You can see the characteristics. You can see 700 bar, 550 bar, 450 bar. So this type of pressure level comes, we can only use radial piston pumps. Okay, high pressure. Okay, high power. Okay, applications, these pumps are used. Radial piston pumps are used. See, high power to weight ratio, highest efficiency, highly reliable, operate at high pressures, good serviceability, provide long life. These are the advantages. Disadvantages: intricate design, most expensive, higher maintenance cost, sensitive to contamination, and limited flow rate. See, normally, piston pumps, normally, whether it is a axial piston pump or a radial piston pumps, it is manufactured to the highest tolerance. Okay, means the gap, the gap will be to the extent of 5 micron, 10 micron level, we can manufacture, so these are manufactured to that extent. Okay, so these are highest efficiency pumps. Okay, this whereas gear pumps and vane pumps, that much efficiency will not be there. Okay, it is a little, say, 10 micron, 25 micron gap will be there in the gear pumps. The efficiency will not be very high. Okay, we are not. So when we want very high efficiency, we go for piston pumps. Okay, that's why sometimes even in the mobile applications, there the efficiency. We are looking for efficiency, so we may use a piston pumps there also.
Sir, could you explain again why do they have highest efficiency?
See how you get a high efficiency. One is the volumetric efficiency. Okay, when you have to reduce the leakage. Okay, another is the frictional forces has to be reduced. These are the two parameters, two important things which is controlling the efficiency. Okay, so how the volumetric efficiency can be, any leakage can be reduced. So you should make the tolerance, the gap. Say there is a fixed part, there is a moving part. Okay, the gap between the cavity and the moving part, like a vane or a gear or a piston, the gap should be reduced. So that is possible. So that is a manufacturing technique. Okay, so highest efficiency if you want, so you could have a good manufacturing process. Okay, so you have to reduce the tolerance. Okay, so see normally when you say 5 micron gap clearance, it is very highly impossible to have a 5 micron clearance. Otherwise, very high cost manufacturing process is required if you want to create a 5 micron clearance. So normally 10, 25, 40 micron, that gap will be there. See, 40 micron is we cannot see with our eyes that gap, even 40 micron. So if you want to have a 5 micron clearance, it is extremely difficult. The manufacturing process the system should be, very highly accurate. Highly costly manufacturing process is involved in that. Okay. See, suppose you want servo valves, proportional valves systems when you are using, you may have a 2 micron efficiency or a 5 micron efficiency required. That okay. So such things are manufactured with the piston pumps normally. Okay. Whereas gear pumps, which are normally used where applications where high efficiency not required. Okay, there is a 10 micron or 25 micron clearance is required. Such applications you can use gear pumps. Okay, vane pumps, vane which is being pushed, from the back, it is pushed. So the clearance is covered. Okay, so there it will be less. Okay, there also it will be less. But not to the extent of 5 micron and all, or 10 micron. 10 micron, 20 micron, 25 micron, that clearance will be there in the case of other pumps. So piston pumps are usually manufactured for high efficiency. Okay, so the manufacturing process will be very expensive. Okay, so we use such systems there where high efficiency is required. Okay, see normally in the mobile applications, we are not getting electricity, we are using diesel engines. Okay, in a mobile application, we are using diesel engines. When you are using diesel engine, always the attempt is to make a high efficient system. Okay, otherwise diesel what you are using, okay, so it is not efficiently utilized. The continuous working, efficiency will not be there. Lot of losses will be there. System will be uneconomical. Okay, so there at such a system, even though the component will be very costly, we may use piston pumps in the mobile applications. Okay, we may use piston pumps. Okay, so sometimes some small pump may be generator pump, charge pump may be used. There you may use a generator pump or a gear pump may be used. Okay, whereas stationary industry, when you are thinking, Okay, we are inside indoor application, stationary applications. We can use a gear pump. So most of the industry system may be gear pumps or vane pumps will be used. Okay, in the stationary applications. Whereas high efficient systems are used, we tend to use piston pumps. Okay, so that is one criteria I'm telling. Okay, other criteria may be the pressure. What pressure level you are using? Okay, we may have a pressure level of 210 bar. See, industry pressure is up to 350 bar. Industry pressure is up to 350 bar. Okay, and that too, again, there are 2-3 divisions. Less than 100 bar one system. Okay, sorry, less than 100 bar. Okay, 100 to 210 bar, there is a medium pressure system. Okay, about 200 to and up to 350 bar, there is a high pressure system in the industry. So industry normally use up to maximum 350 bar. Okay, so there are pumps, designed up to 210 bar. Okay, these are usually gear pumps and the vane pumps. Okay, we may not go for a piston pumps there. Okay, we can use, we can get, but if you want a high efficiency there, may use. Okay, but normally it is gear pumps and the vane pumps are used in such applications. Okay, so selection of pump is a very important issue. Okay, various factors we have to take into account, and then we will be able to decide the type of pump used. And we follow some pattern. See, when we started using something industry, and we continue sometimes. Okay, a new thing comes, may not adapt immediately, so it will take some time to adapt, to change entire thing. Okay, so this way, some particular way, the things are being developed, and we start following, and the manufacturer offering components, and we are forced to buy those components. Okay, so how it has come now, I am telling how the pressure has come. Okay, so US, there is a 1000 psi or 2000 psi or 3000 psi. Okay, that way they developed the components. They started developing components for that pressures. See, when they developed the seal material, okay, see what is inside the component. There is a seal material. Okay, as we develop good seal material, we will be able to use higher and higher pressures in hydraulic system. So there is always a tendency to use higher and higher pressure in hydraulic system. Okay, in pneumatics we are always constant, 6 bar, around 6 bar pressure we are constant. But hydraulic is not like that. See, now present maybe what I am telling typical values may be applicable. But after 20 years, after 30 years, it will change. So industry may use 700 bar. Who knows? So there is a possibility. Industry may use a 700 bar system. Okay, so there is always a tendency to use higher and higher pressure in hydraulics. Okay, so as we develop a material which can withstand higher and higher pressure, we now start using. When manufacture components which can withstand 350 or 450 bar, okay, and we can develop very compact systems can be developed using higher pressure system. So that is the idea. Okay, so these are the things. So let us see the application points. Some of the application points. Okay, say gear pumps. Okay, gear pumps are relatively same thing is coming. No?
Yes, sir. Yes, sir.
Gear pumps are relatively inexpensive compared to the piston pumps and vane pumps. Least expensive is the gear pump. Okay, gear pumps are commonly limited to pressure up to 275 bar. Gear pumps are very common in constant flow, constant pressure applications on mobile equipment because of their low cost and dirt tolerance. Okay, it can tolerate more dirt. Okay, suppose some 10 micron particles are there or 20 micron particles are there. A gear pump can tolerate those contaminants. So it is more tolerant of contaminant. They are widely used as a charge pumps. Vane pumps operate quietly, produces very little vibration and with that.
Sir, there is a question, sir. What is the charge pump? You have said gear pumps
Charge
are
pump
used.
means, see, normally in the hydrostatic transition, in mobile system, there is a pump. Pump is pushing the oil to your hydraulic motor. There is also hydraulic motor. You know the cylinder, hydraulic cylinder. What is the function of cylinder? It converts the hydraulic power into mechanical power. You get a linear. Similarly, there is a hydraulic motor. So your hydraulic power is converted into a rotary motion, hydraulically. Okay. So in the mobile systems, we pump is pushing the oil to the motor. okay, that oil is returning back to the pump. There is a closed loop system, closed circuit system. Okay. In industry system, what we do, we store in the oil in the tank. Oil is taken from the tank, pushed to the system, cylinder, and it come back to the tank. Okay. So that is a system, open system is used in normal industry. Okay. This is called open circuit system. But in the mobile system, we cannot keep a large tank and large amount of oil we cannot keep. The weight will be more, no? The vehicle is moving. So we normally use a closed circuit system. Okay. So pump is pushing the oil to the motor, and then the motor oil is coming back to the pump. That oil is circulating there. Okay. But there will be leakage and some loss of oil will be there. We have to compensate that oil. So we keep another one small pump reservoir tank, and small pump will be used. Whenever some leakage is coming, immediately that will be compensated. That is called a charge pump.
Okay.
In some system now there is a charge pump to compensate the leakage. So whenever the oil leaking or oil temperature is increasing, it has to come back. So there will be a coolant system, heat exchanger will be there, oil will be cooled. So oil will be coming back to the tank. So other side the oil will be pushed into the closed circuit system. Okay. So that type of system is used. That is why there are two types of hydraulics here. There is a stationary hydraulics, there is a mobile hydraulics. I think you heard now, mobile hydraulics. Mobile hydraulics. Yeah, so the difference is that one only. So industry hydraulics, we use the tank, oil will be there, that oil is taken and it is pushed to the system, it will do the work and oil is coming back. You service the oil there in the tank and again, clean oil is again pushed into the system. That is the industry system. Okay. In the vehicles and all outside the vehicle, excavator, all the systems we are using the mobile system. So there we are not using the industry type of hydraulic. Small difference is there. Okay. So that is the closed circuit system is used generally. Okay. So there the charge pump is used. Okay. There is a small pump. Okay. So instead of 100-liter oil keeping in our industry system, there only 5-liter oil will be kept in the tank. So naturally the weight will be less. Your diesel consumption will be less because continuously it is moving. Okay. So diesel consumption will be less. Okay, so that type of
The same concept are used in water jet cutting, I think, because we have the water jet cutting here. So
jet cutting, that is a jet creator. No, that is a jet. That is a kinetic energy. That is another. See, we are using
kinetic energy, but you are saying about charger pump. That I am saying that there is an external charger pump which we have used from an external tank for giving water.
Yeah, that will be coupled to your prime mover only. That charge pump also.
Yes.
Your closed circuit pump also will be there, and same shaft. This one charge pump also will be there. It will be linked the pipe will be going to the closed circuit. One line will be going.
Yes, sir.
Okay. So that is entirely a different hydraulic system. That is called hydrostatic transmission. You heard HST, hydrostatic transmission. HST system. That is a separate hydraulics. You have to study that. Okay. So once the basic is understood, that will be extended to the hydrostatic transmission also. Okay. But there are some differences. Okay, that you have to understand. Because you cannot take everything here in that circuit and all. Okay. So we understand that there is also hydrostatic transmission. HST. Okay.
Yes, sir. Yes, I understand.
Closed circuit. Correctly term is closed circuit HST. Okay. In a hydraulic industry, hydraulic also it's hydrostatic transmission only. Static pressure only we are using. Okay. But it is an open circuit HST. We are using open circuit HST. The mobile vehicles are using closed circuit HST. Okay, there is a difference. Okay. So I understood where the charge pump is used. Okay. So vane pumps operates quietly. Okay, the noise produced is less, produces very little vibration. Okay, and can be easily repaired. Vane pumps are commonly limited to pressure up to 275 bar. Typically, okay. Majority of the vane type pumps have a fixed displacement, but it can be made variable displacement. The unbalanced vane pump can be made as a variable displacement. Okay, if the unbalanced vane pump, your rotor part can be made concentric. You can push it and you can make it concentric. So it can be made a variable displacement also, but not very popular application. Okay, if you want variable displacement, generally we use piston type pumps. This also can be used. Vane pump also can be used. Variable displacement vane pumps are only used for very specialized applications. Now, piston type pumps have a very good service life, provide so good contamination and heat are controlled. They are available with the pressure rating up to 690 bar. Okay, if not even more than that also. Okay, it is available. They are used for specialized applications. The displacement can be varied easily. Best choice for applications requiring high efficiency and high power density. So such application we use piston type pumps. In that, axial piston pumps are available in a wide range of displacement, okay, and pressure capabilities that make them suitable for many mobile and industrial applications. Bend axis pumps tends to be slightly more volumetrically efficient, but also tends to be slightly larger than for a given capacity. Radial piston types are used for specialized application requiring very high power.
Sir, there is some patch on the top of the PPT.
Yeah?
Some patch.
That is something because of the this speaking. See, something is coming here also. Thing. See, because of this one, this is online, so that this can be moved. It will be
1 minute.
Okay. See, some of the pump parameters, how to interpret. See, manufacturer will give a like this. Okay. So suppose when you catalog, when you refer, okay, this is a gear pump. Okay. There is a model number is given. Okay. Particular agro height. Okay. So this is so normally, based on the power rating. See, pumps are usually rated based on the electric motor power rating. So electric motor power rating is 0.55 kilowatt to 3 kilowatt. It is given here. Okay. Based on that, it is given. So that is a pivot parameter, important critical parameter. Okay. Based on that, other parameters are specified. Okay. Suppose you take 0.55 kilowatt. Okay. In that, now what is the displacement available? This is the displacement. See, centimeter cubed. That means cc, cubic centimeter, cc. So these are the sizes of the pumps. 0.8 cc, 1.2 cc will be larger than 0.8 cc. Then 1.66, 1.6 cc, still larger pump. 2.0 cc, more larger pump. 2.5 cc, 3.3 cc. So 0.8 cc when you take, so you can get a 0.55 kilowatt. 0.55 kilowatt. So what will be the liters per minute? LPM. So that is LPM is 1.1 kilowatt. Sorry, LPM. The flow rate will be 1.1 LPM. You can calculate. See, 0.8 is the displacement, cc, into what is the speed? 1395 is the RPM. So 0.8 into 1395 you multiply, divide by 1000, that will be 1.1. Okay, so that you can calculate it. The manufacturer also will give that value. What is the maximum pressure rating? 200 bar. So this much parameter we must be able to understand. Okay. So normally when you design with the power rating. What is output power required? Suppose you want 1 kilowatt power output is required. Okay. Output of the system now 1 kilowatt. Okay. So there will be hydraulic power will be more. So 1.3 kilowatt. Okay. Electrical motor will be 1.5 kilowatt. Okay. So when 1.5 kilowatt electric power is there, okay, that is converted to hydraulic power, it becomes 1.3 kilowatt. Some losses will be taking place. Okay, when it comes to the output, you get only 1 kilowatt. Okay, so when you want a 1 kilowatt output, okay, you should go for 1.5 kilowatt, say 1.5 kilowatt you have to go. Okay, then you can select what type of CC you want, what type of pressure you can select. Okay, so pressure flow combination that will decide the power. Okay, so that is how. So a lot of choices are there for your selection. See 1.5 so you can select from here 2.1 cc, 2.5 cc you can select, 3.3 cc you can select. Okay, so lot of options are there in hydraulic system. Okay, the pump see pump model also changes. The pump model size also changes. So 3 sizes I am getting here. Okay. So this type of, you must be able to interpret the data here. What I mean, why I am taking this, you must be able to interpret the data. So when you are Ongc, when you are buying the pump, okay, you are selecting the pump, okay. So how to select? A lot of options will be there. You should understand the meaning. What is displacement? What is the pressure P here? What is the RPM? Okay. What is the LPM here? What is the bar rating? Bar is the maximum pressure rating. Maximum pressure rating. Bar. Okay. You may not set 200 bar. You may set 180 bar. You may set 100 bar. But maximum rating is 200 bar. Okay. So that is what they have given. Okay. Probably they have given the rating what you want to set. So you want the 0.55 kilowatt. Okay. And when you are using 1.1 LPM, probably you have to set for 200 bar. Okay. You calculate. You can calculate it. The hydraulic power will be equal to P into Q by 600. Earlier we studied now. Hydraulic power is equal to pressure in bar, Q in LPM divided by 600. So probably this will be coming, it will be matching, manufacturer already given. So set pressure will be 200 bar. So that is the rating given by that. So like that, so different parameters, okay, the flow and RPM. When RPM is increasing, the flow rate will increase. Okay, but we normally don't change the RPM. Okay, and your like a pump will be driven by a constant speed. Okay, we are not changing the speed, but changing the flow rate. Okay, we keep the speed constant. Okay, and then we use a variable displacement pump to change the displacement or the flow rate. Okay, we will not change the speed. Okay, because one speed is decided for in the design time, the same speed should be there. Okay, so same speed, 1000 RPM when you take, different motors will give you different output. Okay, this size is increasing. Pump size is increasing. Okay, more output you are getting. So here the LPM. So say this is the model 18, is 25, 35, 40, 50. So as the same speed if you take, okay, then you get a different output. This is a torque versus this one. Okay, torque, theoretical torque is equal to VDP by 2 pi. This also we studied. Volumetric efficiency will be, as the pressure increases, the leakages will be more, his efficiency will reduce. As at 350 bar, the least efficiency you get. Okay, at 0 means 100 efficiency is there. At 100 bar, you have around 90% efficiency. Okay, at 200 bar, you have got at say 82% efficiency. So like that. Okay, so this you must be able to interpret. Noise level data also will be given by the pump manufacturer. Okay, as the pressure is say you set for 200 bar. So different 3 models of pumps are given. So this is the lowest noise producing pump. Okay, for 200 bar. So this much noise will be produced. Maybe say 65 dB is produced. Okay, this pump will be producing around 70 dB noise. Okay, so the comparison of different pumps, you can just go through that. Okay, already I told many things here. Okay, so parameter, okay, design. Okay, gear pumps are external gear pump, simple rugged design. Vane pumps slightly complex design. Piston pumps very complex design. Displacement, gear pumps are always fixed displacement. Vane pumps can be fixed, can be variable. Similarly, piston pumps also fixed or variable. Pulsation, gear pumps are high pulsations. Okay, the output will be high pulsed output. It gives. Vane pumps almost like a continuous flow. Okay, only the vane gap, vane how much thickness, only that gap you will not get output. Otherwise, remaining part will be, you get a continuous flow. Okay, the pulsations are very much reduced in the vane pump. Piston pumps, medium. Okay, we are having pulsed output, but number of cylinders we are using, so we are able to reduce the pulsations. Sensitivity, the least sensitive, fluid sensitivity, maybe to temperature or other contaminants.
Sir,
okay, fluid sensitivity. Yeah.
Sir, if we use bearing air also, we get high pulsation or we can reduce the pulsation, right?
what is a bearing pump?
Herringbone gear pump.
So herringbone and all is there, we will reduce the pulsation, but we cannot use very high pressure or high flow. Okay, it will be still limited. If it is a per gear, no, maybe 210 bar. When you go for a herringbone, you have to compromise for the pressure. Up to that pressure, you cannot use. You have to refer to the manufacturer's catalog. How much is the manufacturer saying maximum pressure can be used? Okay, so some compromise you have to make. You may get a continuous flow. You may the pulsation can be reduced. Okay, but there may be some other problem. So that is why it is not that much used. Very low pressure, low power applications we can use. Okay, so such application you want high efficiency, we can use such pumps. Okay, so you have got a number of types of pumps. Okay, you have to know various factors when you take into account. So many type of things you have to take into account. Okay, one is the pressure. See, very critical thing is what is the maximum pressure rating. Okay, and you selected a pressure. Okay, which is coming within that, you can select. Number of options will be more. But when your pressure is increasing, your options will get reduced. See, some of the gear you cannot use. In that internal gear we cannot will not be able to use. Okay, up to 275 bar external gear we can use. Okay, but so some other efficiency will be less. Okay, when a high pressure you are using, you want cheaper option, you go for gear pump. But running cost will be going high. Okay, your leakages will be more at that pressure. Okay, your running cost will be going high. Okay, so overall, suppose in a service life of 5 years when you take, capital cost and running cost, that is the total cost you have to take. Not so when you are buying, it may get for 5,000 rupees, one gear pump. Okay, piston pump may be 10,000 rupees. Okay, but running cost of gear pump will be more. So over 5 years, you are spending 10,000 rupees as a running cost extra. Okay, so you will not save, that way. Okay, so when you are designing, you have to total cost for the entire service life you have to calculate. That will be the optimum design. Okay, so when you are buying, that time the capital cost, it will be less, means you should not think that we are saving some money. Okay, but running cost, piston pump may be more efficient, 95% efficient. Gear pump may be 85% efficient. So 10% loss will be there. So continuous working, every month you pay electricity more. Okay, so in a year or in a 5 years or 8 years, okay, how much cost will be involved? Extra cost. Okay, that you can find out approximately. Okay, then still you are saving the gear pump. You can have a gear pump. Okay, but you are not saving in a continuous working, then the piston pump may be sometimes better. Depends, application to application, it depends. Okay, sometimes you are not using continuous operation, continuous production is not there. Okay, say some drilling for in our 1 hour, one operation only required, intermittent operation. Okay, so efficiency that won't matter that much. Okay, so many factors are there you have to take into account when you are designing the system. Contaminants, gear pumps are more tolerant. Okay, vane pump less tolerant, because the vanes get worn easily. More contaminants are there. Okay, and piston pumps are manufactured to the tight clearances. Okay, tight tolerance it is manufactured, so it is a very small particle also matters there. Suppose 5 micron clearance if you manufacture the piston pump. Okay, more critical particle size is 5 micron. Okay, if 10 micron clearance is there, 10 micron particle will be more critical. It may get trapped. If 10 micron clearance is there, 10 micron particle may get trapped in there. It will not go out also, it may not come back also. It will be trapped in between. In the moving, some part is moving, it may get trapped. So that is more critical for hydraulic system. So generally piston pumps are manufactured with a tight tolerances. So it is more sensitive, contaminants. Maybe gear pumps 25 micron tolerance it is manufactured. Okay, so all particle below 25 micron no problem. there. Okay, so it is a good. Okay, it is more tolerant there. Leakage. Okay, because gear pumps are prone to more leakage. Okay, more leakage will be there, less efficient, less prone. Okay, prone to leakage. The piston, see why it is less prone means it. See, even if it is wear, veins, it is getting wear. Okay, again it will be pushed. Okay, again the tight clearance, not tolerance, tight, this will be there. Okay, it will be tightly, in contact with the casing. So there will be, but what we need is only uniform. All veins should wear uniformly. Then there is no problem. Only one or two veins are only wearing too much, then it is a problem. If all the veins are wearing uniformly, then there is no problem in a vein type. So it is a less prone to leakage. Noise level high, vein pump low, and piston pumps are also high noise producing pump. Size is small to medium. This is medium to large size. Okay, large power, large size pumps. It is a piston pumps. Power to weight ratio low. Gear pumps are low power to weight ratio. See, 1 kilogram weight, if you consider, how much power output? Say 5 kilowatt. 1 kilogram gives a 5 kilowatt. Okay. So, if a vein pump 1 kilogram, also less only you get. Okay. Whereas 1 kilogram can give a 10 kilowatt in the case of piston pumps. Means power to weight ratio will be better in piston pumps because you use a high pressure. In piston pumps, you use a high pressure and the size will be reduced. Okay, weight will be reduced, but you get more output, more kilowatt. That's why the large power to weight ratio for the piston pumps, mainly because of the high pressure application, high pressure usage. We use high pressure in piston pumps, so that's why it is a power to weight ratio will be high. Efficiency least for gear pumps, medium for vein pumps, and highest even greater than 95%, and all we can see in the manufacturer's catalog the efficiency offered by the manufacturers for the piston pumps. Cost cheapest is gear pumps, and vein pumps medium, and piston pumps very costly. Okay, these are okay.
Okay, sir, but it's 1 o'clock.
We have to give a break.
Okay. So now, see, I almost completed. Okay. So the pumps are almost completed. These are all already we discussed. Okay. So, now actually the time for lunch. Okay. Whatever your doubts, you can type and you can record it. We will discuss afterwards. Okay. So far, whatever doubts are there, you can ask. Okay. So now we'll break for lunch. After lunch, we'll again discuss. Okay, your questions. Okay. After that, I will be taking about pressure control valves and pressure relief valves. Okay.
We'll come back after an hour. So is it fine?
2
Okay,
o'clock,
sir.
is it okay?
Okay, sir.
Yes, ma'am.
Okay, sir. Okay, sir. Thank you.
Thank you. Please join this session. We're going to start the class within 2 minutes.
So good afternoon, participants. Okay, we'll continue now. Okay, so in the morning class, I have taken hydraulic pumps. Okay, so we have seen different types of pumps. Okay, pumping action. Okay, we have also seen the some mathematics. Okay, some relations. Okay, like volumetric displacement. Then we have seen theoretical flow rate, actual flow rate, leakage. We have seen that torque. We have seen input power, output power. We have seen various efficiencies, volumetric efficiency, okay, then mechanical efficiency, overall efficiency, okay. These are the main important, okay, in the hydraulic pump as far as pump is concerned, okay. And pump is the main component in hydraulic system. Pump is the heart, okay, heart of the system. It is pumping the oil, okay. So all depending upon the pump. So that also we have seen. Then we have seen the constructional details of the pumps, okay, and comparison also we have seen, okay. All pumps are working like same one principle, the pumping action, okay. So that type, if you see any pump, you will be able to understand easily, okay. Only thing, what is the mechanism used to create the pumping action? So that also you have to understand, and it will be easy to understand. Now I am going to talk about pressure relief valves. Okay, hydraulic pressure relief valves. Okay, so we know that hydraulic system pump is creating the flow. Okay, the pressure is created when the flow encounters some difficulty. Okay, the pressure develops. Okay, and pressure can develop to any value. So we have to restrict the pressure. Okay, So that we are doing through the pressure relief valve. Okay, you can see the pressure relief valve, and pressure relief valve is given here. This is a direct acting type pressure relief valve. This is called the direct acting type pressure relief valve. One more type is there, that is the pilot operated type pressure relief valve. So basically two types of pressure relief valves. This is a direct acting type. Okay, we'll see the working of this one. Okay, there is a puppet. Okay, there is a corn puppet is there. Okay, and there is a valve body is there. There is a inlet. Okay, the pressure P. Okay, P is the inlet and T is the outlet. Okay, is a tank. T means tank, P means pressure. And there is a spring, and there is a can control the spring tension by a knob or a screw, like that. You can turn this one. You can control the spring tension. Okay. So in fact, you are setting the pressure by setting the spring tension. Okay. See, associated with the pressure relief valve, also there will be a gauge. So you will see the gauge and you turn. Okay, what pressure you want, and you can set it. Suppose 100 bar is required. You turn this one and the pressure increasing 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. When 100 reaches, you stop. That means you are setting the spring tension for 100 bar. Okay. So what happens is when the 100 bar pressure is developed in the system, okay, this corn will be pushed and there is an opening from P to T. So it is diverting the flow from the pump. So instead of going to the system, okay, and pressure is developed, the flow will be diverted to the tank. Okay, it will maintain the pressure in the system, but excess flow will be diverted to the tank. Okay, so that is a function of the pressure relief valve. So this is a pressure relief valve. Normally it is closed. Normally when there is no pressure is less than 100 bar, okay, or when there is no pressure because of the spring, it will be closed. Okay, the valve seat will be tightly closed. Okay, so when the pressure increases, okay, and when 100 bar is reached, the flow is diverted to the tank through the pressure relief valve. That is how this is working. This is a symbol of the pressure relief valve. Okay, here the P port. This is a puppet. Okay, the puppet is being acted upon by two forces. One is this. See, this is this is coming from. See, I will show with another. See, like this. So this is actually the thing. Pump is creating the flow. Initially, flow will go to the system. Initially, goes system. When pressure is less than the set value. What is the set pressure? PS. Okay. If pressure is less than PS, the flow will be going to the system. Okay. When the suppose cylinder is moving, okay, the pressure will not develop. When the cylinder motion is completed, the pressure start developing. Okay. When the pressure becomes 100 bar, this PRV, pressure relief valve will open, and the flow will be now diverted to the tank, maintaining the system pressure. It maintains the 100 bar pressure, or a PS pressure. PS will be maintained. Okay, and excess flow will be diverted. It will not allow the pressure to increase more than PS. That is the working of the pressure relief valve. Okay, so this puppet is being acted upon by two forces. One is this force. Okay, pressure into area. Okay, the area is there, the pressure is there. The force will be acting downward. Okay, against the spring force. Okay, opposite you have the spring. So acting on the puppet. Okay, if your hydraulic pressure is more, it will move and P to T will be connected. Okay, and flow will be going from P to T. This is how this is working. Okay. So now whatever I talked, say when the particular pressure is reached, the pressure relief valve will open and divert the flow. Okay. So this is an ideal situation. Okay. It is not a practical situation. Ideally speaking, when that pressure is reached, say when that suppose as a numerical value, if you set for 100 bar, okay, when 100 bar is reached, it will open, okay, and the flow will be diverted. Okay. But actually speaking, before 100 bar itself, the puppet will be opened. Little opening will be there. No? Suppose 100 bar when you set, probably 70 bar, it's slightly lifted. The puppet will be slightly lifted. And if there is a continual flow, okay, just a continual stream of flow will be there. Okay, and that pressure is called cracking pressure. At what pressure the puppet opens, that pressure is called the cracking pressure or the pressure relief valve. Okay, which is the minimum pressure developed. Okay, or the pressure developed so that there is a continual flow through the pressure relief valve. Okay, not drop by drop. Okay, there is a continual flow through the pressure relief valve. That pressure is the crack pressure of the pressure relief valve. Okay, again the pressure increases 70, 80, 90. Okay, when 100 bar is reached, the puppet will be fully opened. That time the complete flow will be going through the relief valve. At 100 bar, the complete flow will be going through, going to the tank through the relief valve. That pressure is called the full flow pressure. Okay, so suppose here cracking pressure is 70 bar, full flow pressure is 100 bar. Okay, so there we got two important parameters. One is the cracking pressure, and another is the full flow pressure. Okay, the difference is called pressure override. Okay, 100 minus 70, there is a 30 bar is the pressure override of the pressure relief valve. Okay, the difference between the full flow pressure and the cracking pressure is called the pressure override of the pressure relief valve. Okay, is it desirable? The pressure override is desirable or not? So you set for 100 bar. Okay, we expect 100 bar it opens and relieving the complete flow. Okay, so that is what we expect. But 70 bar itself it gets open and some small flow will be going through the relief valve. Okay, we can think that as a leakage. Okay, we don't want from 70, 80, 90, 100 or below 100 bar the flow going through the relief valve. Okay, so the pressure override is not really not required, not desirable, but we cannot avoid. Okay, there will be, because there is a spring is the other side, it gets compressed little bit and the flow starts. We cannot avoid it. Okay, so but we can reduce the pressure override. Okay, instead of 30 bar pressure override, we can reduce to say 10 bar pressure override. Okay, we have to use another type of pressure relief valve that is called pilot operated type of relief valve. Okay, so that type of relief valve also there. Okay, now we'll see you can see, okay, just a demonstration of the when pressure is developed, say 10 bar setting. Okay, when the 10 bar is reached, it opens, the flow will be diverted. So now, okay, so like that. When pressure reduces, it will close. This characteristics we get to see again. Okay, so this is the ideal situation we told earlier. Suppose so you set for maybe this is 105 bar. Okay, suppose this 105 bar, if you set at that point, it opens and the full flow will start. This is an ideal situation. This is the actual situation. Okay, so initial opening, the 100 bar now it's a cracking pressure. Okay, as the pressure increases, 100 to 130, when it comes, you have the full flow pressure. So you have 30 bar pressure override here. Okay, so this is opening. The valve is opening and fully opening. Here it's fully opening. Okay, so this is how the characteristic goes. Okay, now when the pressure reduces, we start closing. The closing characteristic is different. Okay, it will not come the same way. Okay, so it will take some more time to close. Okay, so even if 100 bar is reached, it will not close fully. There will be still some flow will be there at 100 bar. You have to apply, reduce the pressure to say 75. Okay, then only fully closed. This is a closing pressure. So cracking pressure is 100 bar. Okay, there is a full flow pressure is 30 bar. Closing pressure is 75 bar here. Okay, so there is a difference here. This difference is called hysteresis. Every valve will have a hysteresis. Okay, it will not go. Say when the pressure is increasing, it goes through some curve. When it is pressure is reduced, it takes a different path. Okay, so that is how it is coming. So this is how it is behaving. Okay, so here the pressure override is 130 minus 100. That is a 30 bar pressure override. Now, what are the problems of direct acting type pressure relief valve? So one problem is the non-linearity of the spring. Okay, the spring may initially gets compressed easily. Okay, afterwards, it is difficult to compress it. Okay, So there is a non-linearity. As in the case of this direct acting type relief valve, okay, it is affected by the non-linearity of the spring. Also the back pressure. Okay, what is back pressure here? See, you are connecting to the tank. You're going to the tank. Okay, there may be many other connection coming to the tank. See, other cylinder is coming. That is also connected to the tank. So that is also relieving the pressure. Okay, so there will be some pressure at the back of the pressure relief valve. Okay, suppose there is a 5 bar pressure here. Okay, you are setting for 100 bar. Okay, so spring tension is for 100 bar. Okay, back pressure is for 5 bar. Okay, so you are actually setting for 105 bar. So when you set 100 bar, you are actually setting for 105 bar. Or probably we can think if you see the gauge and see 100, probably 5 bar back pressure is there, means it is 95 bar. You are setting it for 95 bar. Okay, so because of the back pressure, your setting will change. That is the meaning. If there is a back pressure in the relief valve, your setting will change. Okay, but we cannot predict the back pressure. Okay, back pressure may be there, may not be there at a certain time. Okay, sometimes more back pressure will be there. Okay, then whatever you set for certain pressure, that will change. Okay, that is the problem with the direct acting type pressure relief valve. So it is affected by the non-linearity of the spring and any back pressure on its discharge side. Okay, so what is the back pressure is unpredictable. If we know correctly, always 5 bar is there, you can set. Then 95 bar you would have set. But you cannot predict what will be the back pressure. Okay, so we see the some advantages and disadvantages. Okay, direct acting type PRVs are simplest and low cost. They are rugged design, high temperature capability, and there is a quick actuation. Because directly you are acting no pressure. Directly, immediately pressure acts on this. So immediately the response will be there in this case. That may not be there in the pilot operated type. Immediate response will not be there in the pilot operated type. There is some delay will be there. Here there is a direct. Okay, so that is an advantage. Quick actuation. Disadvantage, excessive leakage will be there. Your pressure override is more. So there is a large leakage, sensitive to the effect of back pressure, unsuitable for high pressures and high flows. So this is generally used for low or medium pressure, medium flow. We can use direct acting type PRVs. It has got low precision because of the back pressure. See, in the manufacturer's data, when you see, you will have a, you have to specify direct actor operated type pressure relief valve. You have to give something DPR like that. Okay, this is a particular manufacturer. Okay, how the knob, whether screw type or hand knob required, you can specify. Sizes, valve sizes are normally some particular sizes will be specified: 6, 10, 20, 25, 32, like that. Okay, probably this is what I feel is like that particular manufacturer of some size, or there is a standard NG6, NG10. Okay, that is as per some standard. People follow the NG6, NG10, NG20, NG25, NG32. Okay, so for example, if it is NG6 means maximum 80 liters per minute it can pass. Okay, so that is specified somewhere. Okay, NG6 means up to 80 liters per minute it can pass with a minimum pressure drop. That is the size. Okay, they will give, if you see the catalog further, 6 means what is the flow rate allowed in this through this relief valve, that will be specified. Then there are different varieties. Constructionally, cartridge type is there, threaded type is there, subplate type is there, ISO mounting is there. So that you have to, how this is managed, how this is, what type of, how you are going to mount, how you are, there is a cartridge type valves are there. Okay, you are going to ports are threaded type. Okay, ports will be threaded, and you are connecting the hoses or pipes, tubes to the pressure relief valve. Okay, or subplate. So you are going to connect this one to the one subplate will be there. In that, all the connections will be there. Only you have to just fit that pressure relief valve on the subplate. Okay, no connection. Apart from the connection, remaining all things are there in the pressure relief valve. Okay, you will connect to the subplate where all the P connection, T connection, everything will be made, so that you will not disturb when you want to replace. Only that pressure relief valve part you will take without changing the connection. Only that part can be replaced. Okay, mounting ISO is also there. Different type of mountings are there. This ISO, most of the parts of the world use ISO type. Okay, there are some SAE or NFPA. There's are Americans, they use different mounting dimensions. Okay, so the holes and all, that should match. Okay, so that is specified in the standard. ISO standards are there, NFPA standards are there, SAE standards are there. Okay, so they're asking that what type of standard we are using, that you have to specify. Here, this is the, I think these are the factory standard, okay, threaded type. Okay, these are not very important for us. This is the 25 is the pressure. See what pressure rating you are using, so that we can specify here. 25, 50 bar, 100 bar, 200 bar, even up to 630 bar available. This pressure, direct action type pressure relief valve. See this one, Ongc means, okay. So this is a very conservative 40. Okay, this is up to 80 also it is possible. Actually, this is not a constant. Okay, it may be from 40 to 80. But it should, at any point, at a point of time, it should not cross 80 bar, 80 LPM. That is the meaning. So, same valve itself, see, P to T or the flow will be from one port to the other port. Okay, in other path, the flow will be different. That also possible. So that's why, so this is a very conservative 40 liters per minute I have given. Okay, probably this may be even up to 80 liters per minute. It is okay. So that is the Ong size. Okay. So Ong6, Ong10, these are valve size. Valve size. Okay. They normally specify in terms of the Ng 10, 16, 25, 32 like that. Generally we use 6. Most of our application Ng on Ongc also we can see Ng6 or Ng10 will be used. These are generally used. These are very high flow. See the 400 liters per minute.
What is NG?
NG is, I am also not able to get what is that NG. Okay. It has originated from the DIN standard, German standard. Okay. So I searched maybe, all this time, years, many days I searched. What is the meaning of NG? I could not get it. Okay. This may be some German, probably maybe N or G, something like that. So NG, it has started from the DIN standard, German. Okay, but people are using NG, NG6, NG10. I searched in the last week also, 2-3 days I searched for what is the meaning of NG. I could not get it. If you can get, you can kindly give to me.
Okay,
so
sir.
I searched many, all these years also I am searching. But last week also I was, due to some reason, I want to know what is the NG. I could not get the meaning of NG. Okay. But see, that is one thing. But Ng6 means what? How much maximum flow it can allow. That much if you know enough. Okay. That's why I told 80 liters per minute. Okay. So some manufacturer you see Ng6, they say 80 liters per minute. Okay. In that itself 80 also, see suppose P to A and A to T coming. So P to A will be, they will say 80 liters per minute, but A to T will be only 75 liters per minute. That also they specify. Whatever paths are possible through the valve, each path, how much flow rate there, in Ng6 valve also they will specify. The graph will be given. So we can find out. So I given 80 liters per minute for Ng6. I have not seen anybody giving more than 80 liters per minute. That's why 80 is some particular value. That is important. Okay. Probably it may be still less only, but not more than 80. Okay. So individual manufacturer you have to see, and what is the meaning of size what he has given and what liters per minute it can allow, so that you have got a reasonable pressure drop. Okay. That is the idea. So that you can find out. Understood? So any component between the pump and the cylinder, okay, it has to pass the flow. Correct? Any say pump is there, and the other side your cylinder is there. In between relief valve is there, direction control valve is there, check valve is there, flow control valve is there. All valves are in between. Okay, this flow is going through that. Okay, it should not cause more pressure drop. Okay, suppose you generate 100 bar. Okay, in 10 bar is dropping through the component. A lot of energy loss will be there. Any pressure drop is a energy loss. Okay, so you generated pressure, but it is lost across the component. Okay, that's why say these are all found out for a 1 bar pressure. See, any manufacturer will specify. Okay, probably for the what flow should be there for getting a 1 bar drop. Okay, so that is how that flow they will be mentioning. Okay, suppose you pass 40 LPM, the pressure drop is 0.5 bar. Okay, you pass 80 liters per minute. That time the flow pressure drop is across the valve is 1 bar. So they give the specification as 80 liters per minute. Okay, to create a 1 bar pressure drop, what should be the flow? Okay, so that is how they are normally. Okay, sometimes we have the valve that factor. What do you call valve factor KV and CV. This is another way of specifying the size of the valve. KV and CV. KV for metric units, CV for American units. Okay, valve coefficient. This way also. But most of the time people are using Ng6. That's why we are concentrating here. But some manufacturers will say KV, CV value they will give. Okay, from that you can get a flow rate capacity. So general idea I am giving now. Okay, whenever you are coming across the sizing of the valves and all, these factors are important. Okay, now we'll see the pilot operated type pressure relief valve. Okay, this is a pilot operated type pressure relief valve, PRV. Okay, so whatever we have seen already, that is it is still there. The pilot, there is a puppet. Corn puppet is there, spring is there, there's a P is there, T is there. This is what we have seen. This part we have seen. Okay, so now we added some more thing. Okay, there is a pilot valve is added here. Okay, and there is a path created from P. It is going to the other side of the puppet. Okay, like back pressure. Okay, we ourselves is providing a path for the oil to flow and create the pressure here. Or whatever pressure is created, that will act on the puppet. So now the same pressure acts on the both sides of the puppet. Okay, that's how it has been made. Okay, sometimes instead of taking path like this, okay, one passage is made like this, but just one small hole if you make, then also flow can reach other side. Some manufacturer will make a hole here. So this passage will not be there. This will not be there. Just one hole will be made here. So this P small through that it goes to the side. Okay, so what will be the forces acting on the puppet? So here the P into area of this one, okay, that is trying to open the puppet, okay, and the other side pressure and the spring trying to close the puppet. Okay, so you can see that area of the puppet on the closing side will be more. This will be more area also, pressure is also there. So there will be more force closing the valve. Okay, so now if you are applying, okay, say our 100 bar pressure example we take, okay, so when 70 bar reached also, 70 bar here, 70 bar here. So 70 bar corresponding to that force, downward spring force, it will be tightly closing the puppet. Sorry, yes, this puppet will be tightly closed. Okay, but the 70 bar is also acting on the pilot valve also. Okay, there is a light spring is there. Okay, you set it for 100 bar here. Okay, so when the pressure is 70 bar, it will not open. Okay, so when the pressure is 80 or 90 bar, maybe little open. Okay, that time little say 1 mm lifted here. So this oil will be going to the tank like this. Okay, so again that will be compensated. Pressure will be again compensated. Okay, so but leakage will be there. Slight leakage will be there here at 90 to 100. So when it becomes 100 bar, what happens? When it becomes 100 bar, it fully opens here. Okay, the complete oil here will be exhausted. Okay, it will be going to the tank. So suddenly the pressure drops here. Okay, suddenly the pressure drops at 100 bar. This will be suddenly getting opened, and the complete flow will go to the tank from here. Okay. So now here, in this case, what happens? So 70 bar, it is not going to open. Okay. 80 also will not open. At 90 bar only slightly it's opening, some leakage start here. So 90 to 100 bar is the leakage. Your pressure override is now only 10 bar. 90 to 100, 10 bar pressure override in this valve. So leakage is reduced here. Okay. And there is a, so that is how this is working here. Okay. So this is the pressure, pallet topper type pressure relief valve. Okay. So there is a little restriction is given here. Okay. So some delay should be there. So as soon as pressure develops, immediately little, say 1 second or 5 seconds, after that only pressure comes here. So this will be developed here and it will be tightly closed. So this way. What about the symbol? So this is our main pressure relief valve. This is a main pressure relief valve. Okay, main valve is here. The P is coming here. Is that pallet pressure is acting. This pallet pressure is acting here. Okay, on this one. Okay, and it is diverted to the through here through this. It is diverted to the other side of the puppet. Other side of the puppet. Okay, so this puppet is concerned. This one side there is a pressure is acting. Other side also pressure is acting. Okay, and spring tension also acting on this side. Okay, so this is the main puppet valve. Next, after that, this pressure it is acting on the pallet valve. This pressure is acting on the pallet valve. This is a pallet valve. This valve is it is here. The pallet valve being acted upon by this pressure. Okay, and when the pressure is reached, it will open, and then the flow start. It start relieving the pressure from this side. This pressure will be relieved and go to the tank. So this is a symbol of the pilot upper type pressure relief valve, but this is a little bit complicated, no, in drawing or to, no. So sometimes, you know, to make out, okay, because you know this one, you are able to understand. Otherwise, sometimes it will be difficult to understand. Okay, to simplify things, you know, we use this symbol. See, normally we use this type of thing. If you see, this is a pilot operated type pressure relief valve. It's a P to T, and this one. And this is a returning back. This is a spring, adjustable spring. This is adjustable spring. So that is also shown here. So this is a generally used symbol for pilot operated type pressure relief valve. But somewhere if it is given like this also, you should understand that this is a pilot operated type pressure relief valve. Okay, here some animation is there. You can see here. Okay, so then the pump is working and motor is the hydraulic motor. It is rotating. The pressure is increasing. The pressure is increasing here. Okay, the flow is coming here. Okay, now little leakage started here. Little leakage is starting. Okay, now it is fully opened. It is fully opened. Once again, you can watch. So now the starting. Okay. So the pump is working, the motor is rotating. In high torque is given, the pressure start developing. When the torque increases, okay, the pressure increasing. Okay, now the pallet valve is a little opened. Okay, the pressure is going through the pallet operator valve. Okay, the main valve is tightly closed. Now that is opened. The full flow now goes through the main valve. The main advantage is that the pressure override we are able to reduce. Pressure override is reduced in this pressure pilot upper type PRVs. Okay, and also there is no effect of back pressure. See, we ourselves give a back pressure here. Okay, there is no effect of back pressure. Any back pressure also no problem here. So effect of back pressure is minimized, reduced. Actually, you can see one more thing. Okay, there is also one solenoid valve is given here. Okay, a solenoid valve is there. Okay, normally it is closed. So normal application it is closed. Okay, but you know you can remote control the pallet valve. Suppose you want to relieve the pressure remotely, electrically you can operate the solenoid valve. At that time, this valve will be opened. Okay, and this valve will open, and now this pressure will be going to the tank. when this is opened. Okay, this pressure can be relieved. Okay, and that you can do through remote operation. So that's why this is given. This opening is given. Normally this will be tapped. Okay, there will be a tap. So you are not using it. When you want to use it, then you can connect to a 2x2 valve or 2x2 solenoid valve, and remote place you want to control that relief valve. That is possible. That's why this is given.
Sir,
Yeah.
sir, this puppet and pilot operator valves are set in different pressures or what, sir?
No, same pressure only. See, you set the pressure, what pressure you want only you will set. Suppose
Okay.
180 bar you want to set, you set 180 bar only. Yeah. So you set 180 bar, but the accuracy may not be very good in the direct acting type. Okay. Sometimes
Okay.
even 175 bar it may get opened. Because some 5 bar back pressure is there. You, no, 175 bar it gets opened.
Sir, actually,
really,
in this animation, what is actually happening, what I understood is when the pressure got increased, the pilot got operated, but the puppet was not operated.
Puppet operating. See, pilot operating means, see, suppose that 100 bar example if you take, see 90 bar is slightly opened. Say 1 mm lifted. Okay. So little oil is going out. Okay. And also oil is coming into this also. Flow is coming into this also. Okay. So it is immediately compensated also a little bit. Even though a little delay will be there. Okay. So up till
Delay is there, sir.
Some little delay will be there because we are using a relief, some throttling. No? Suppose
It is not only at the closing time, it is also at the opening time also. When the pressure got increased, initially the puppet is moving, but the pilot is moving, but the puppet is not moving. It is taking
it will
time
not move
to
initially.
it is taking time to open.
Yeah, it takes time. Response time is more in pilot operated PRV. See, direct acting type PRV may be 5 seconds. Okay, this may be 15 seconds. Sorry, milliseconds. Okay, the response time is more for the pilot operated PRV. That is one drawback of this valve. The response time is more. Okay.
Okay, sir.
Okay, response time is more. But the direct acting type PRV can be used for low pressure, low medium pressure, or low flow. High flow you cannot use. Okay, suppose your flow rate is high, then you have to use the pilot operated type only. Okay. So this is used where the flow is high, pressure is high. We have to normally use the pilot operated type PRVs. Even the little delay is there in the response, but it is normally used. Whereas direct acting type is used when time critical application. Suppose any very shock pressure comes, suddenly your system should be shut down or relief should be relieved. See, some systems are like that, time critical, and something shock, it should not take more time to relieve. Suppose when shock pressure comes, such type of application, if you use a pilot operated type, then there is a problem. There you have to use a direct acting type pressure relief valve. Okay, and shocks are more, such application direct acting type to be used. Because pilot operated type is having a little delay in responding. Okay, so when the 200 bar is reached, okay, so a little some 10 millisecond or something, more it will take to respond.
Sir, but this mechanism is like showing very
complicated.
Complicated. Like
No, this is a very. This is, if you understand this one, see how this is working. Okay, when you see actual manufacturer's figure, it will be more complicated. This is the simplest of the pilot operated type PRV. Okay, this is
but in direct, it is only a simple puppet which is
so only this is there, one P is there, one T is there. There.
Yes.
Here, one path is provided to the other side. The flow should come to the other side. You can make a hole also here. Okay, directly flow will come here and it will fill up. It will go through like this. Okay, I will show some of the manufacturer's figure. Okay, it will be more complicated.
Okay.
This is a general setup. Understand what is the basic idea here. Okay, that is enough. The manufacturer is given like this. Okay, you may get little confused now. See, like this, then this flow is going, some restriction here. Okay, it goes to the pilot operator valve. Okay, and this is coming here, acting on the other side. Okay, this is still a little same way it is there. Okay, the same thing in another way drawn. Clear?
Yes, sir.
This is actual manufacturer's figure. So where is your P? This is a P. This is a P from the pump. Okay, it is coming. This is a tank. The pump is coming. One small hole is made. Correct? The flow is going to the other side of the puppet. This is a puppet. So both sides now, see, forces are acting. One upward force, one downward force. Downward force will be more initially. So it will be tightly closed. The valve will be tightly closed. Okay. Then this flow is going to the pilot valve here. The pilot here. Okay. When pilot opens, okay, some pressure override will be there. After that, it will fully opens. This flow will be going to the tank like this. To the tank. Suddenly, when this flow is relieved, this main puppet will open. From P to the T, it will go like this.
Yes, sir. Yes, sir.
So, even though I have given one figure like that, sometimes manufacturers, when you see, it will be different. But the same thing only will be there. We have to make out how it is. It will be same idea only. It will be like this. So this is some manufacturer's site I have taken. So this is how they manufacture the valve, the cross section. These are pilot upper type PRV. Okay, so now we see the characteristics. Okay, so this earlier we have seen 100 bar cracked open and 130 bar fully open. This was the direct acting type. In pilot upper type, see 150 maybe 120 bar only cracking pressure, 120 bar, 130 bar fully open. So 10 bar only here pressure override. Okay, this is more steep in pilot upper type. So there is an advantage. Your pressure override is reduced. Okay, you are avoiding the leakage. Okay, you are reducing the leakage. Okay, there is an advantage of pilot upper type PRVs. So when large flow, say 100 LPM, 200 LPM and all is there, more leakage is there now, more energy will be lost. So that is why this is pilot upper type PRVs are used. Only time, as I told earlier, from time critical application, when there is a sudden opening is required, that time we have to use a direct acting type of pressure relief valve. Back pressure I explained. So you can compare direct acting PRV and pilot operated PRV. Direct acting type PRV is a single stage construction. Only one stage. Pressure acting on the puppet. That will open or close accordingly, flow will be diverted. Here, pilot operated two-stage construction. Okay. First stage, then two stage, second stage only the pilot valve only opening and controlling that main valve. The second stage controlling the first stage. Then employs a large control spring. Here use a small control spring. Here large pressure override. Here smaller pressure override. Used for low pressure, smaller flows. Here for high pressure, heavier flows. Lower precision in the case of direct acting type PRVs. Here you got a higher precision. Direct acting type PRV is just enough seat and reseat tightness. There is excellent seat and reseat tightness. See, we back pressure like we create and we tightly close the main puppet. So excellent seating and tightness. And direct acting type is sensitive to the effects of back pressure and non-linearity of the spring. Whereas this is insensitive to the effects of back pressure. The characteristics can see the Parker, I have taken. So this is a design. NG10. See, they got size from NG10 to NG16, NG25. Mounting interface, they given ISO 4401 is a normal mounting interface ISO standard. So these are the holes and all. No? See, mounting holes, hole to hole distance, all those things is specified in the standard. So when you replace an ISO valve, you can replace with ISO valve. Okay. So when an old valve is ISO, okay, then you want a NFPA valve, it is sometimes problem. So ISO valve when you are replacing, you have to use ISO type only you have to use. Then the holes and all will match because it is as per some standard. Okay, so that is how, that is the meaning of this. Mounting position, whether it's vertically to be mounted or horizontally or any position it can be mounted, any position it can be mounted. Ambient temperature up to 60 degrees centigrade you can use. Because of the internal seals and all you are using. So that's how this is deciding. Hydraulic maximum pressure is 350 bar. Fluid is hydraulic oil to ISO. What is this? ISO to ISO. Then fluid temperature to 60 degrees centigrade. Viscosity up to 80 CST is the viscosity. Maximum viscosity 80. Okay. Permitted is up to 380. So normally recommended is from 30 to 80 CST. mm square per second is CST. Sandy Stoke. Filtration, you studied this one, 18 bar, 16 bar, 13. Fluid, okay, there is contamination, how you specify. There is 18 bar, 16 bar, 13. These are some cleanness level of the hydraulic oil. Madam, this take a cleanness level.
No, sir.
18 bar, 16 bar, 13.
Mhm.
Okay. Okay, no problem. Okay, this is there. And this is the connections. Okay. These are all something more you have to learn. Then only here and only you will understand. Okay. So this is the, so like that, the specification also we must be able to understand. Okay. The sun is gone, na?
Oh, yes, sir. I will give a
I'll
small
see.
break, sir.
Okay.
Small break. Will give.
Okay.
Can we take a small break?
Okay, ma'am.
Okay. After 10 minutes, we'll come back again. Okay.
Okay.
fluid sim I will share.
Welcome back.
But here it is not there.
Start coming, sir.
How it has gone? Even Webex also not there. This is a fluid sim. So I will go my.
And share.
How it has gone?
Can you hear us? Hello?
Yes, ma'am. Yes, ma'am.
Okay, shall we start the class?
Yes.
Okay.
Join the meeting.
Join.
Starting a meeting. Or browser.
Just to share the meeting,
yeah.
sir.
Already.
No. Just it was there, sir. Here it is. Okay. Just click on this side.
It has come here. It's open.
No, sir. Close it, sir. It's you.
Okay.
This is only sir. Join the meeting. Next. Yes, sir.
You need not do anything.
Yes, sir. Has come, sir. Share the. Yes, sir. Share the.
Okay.
Sharing the content. Come, sir.
Okay.
They are asking this fluid simmer whether it is available for this version, like learning version. No, sir. 3.3 was there, sir. That demo version we had. No? That I have sent.
Okay. Okay, we'll start. Are you able to hear?
Yes, sir.
Okay. So what I am going to do is now we'll see the fluid sim hydraulics simulation software. We'll see some of the circuit, how to develop the circuit, okay, and some idea of how to set the pressure and all. Okay. So this is a fluid sim. I think you are able to see this fluid sim hydraulics software. Okay. You can see the component library where all the components are here, like power pack, then pumps, then accumulator, filters, cylinders. Okay, so many valves. Then you have the other components, check valves, and other components are here. The pressure control valves. There are many components are available. Okay, there is electro hydraulics. Electrical components are also available. So first you have to start open a file. New file can be opened. So you can click new. So this is opened. Then you can select the components. You can drag and drop it into the file. Okay, so this is a power pack. In the power pack, you can see the pump. There is a motor coupled to that. There is an inbuilt relief valve. Okay, which is set the pressure of 60 bar set. I can change. So I can change it to 200 bar. Okay, maximum up to 400 bar I can set in the software. So 200 bar I set. The flow is 2.4 liters per minute. Okay, up to 500 bar I can 500 liters per minute I can set. So now it is a default 2.4. So that is there. Internal leakage is there. Okay, that is also 0.04 some unit. It is there, and this is the pressure I changed. Okay, only pressure I changed. Now the pressure is 200 bar rating. This power pack working. Then you can select one cylinder. The cylinder. Then this is controlled by 4x2 valve. I think you know this 4x2 valve. This is a 4x2 valve. P, P, A, B. 4 ports are there. 2 positions are there. That is why it is called 4x2 direction control valve. And this actuation you can add. Okay, so here the manually operated valve. This is manually operated actuation, left actuation. Manually you can see different symbols. Okay, so this is a lever operated valve. Okay, I selected some lever operation. Spring return, that is selected. Okay, so this is the valve. So some hydraulic resistance I made minimum, so that the size of the valve is increased, or I set the correct size of the valve. So hydraulic resistance I made a minimum. So this is this one. Here this is connected to the pump. Okay. Now what about the relief valve? So this relief valve is for the internal. Maybe it is inside the power pack. Manufacturer set for 200 bar. Okay. So normally we will not be able to change afterwards. Okay. Otherwise you have to open the power pack and all, and you have to change. So that is for the safety of the power pack the manufacturer has provided. So that is say 200 bar rating the power pack is there. All components are rated for more than 200 bar. So then you can set 200 bar pressure. But I am going to use less pressure. Say maybe 150 bar only I am going to use. Okay. So I will have one more relief valve, pressure relief valve. I use a relief valve, which is set at you can set at 150 bar. 150 bar. So that is connected to the pressure relief valve should be connected to the pump output. Okay, say pump output, it will go to the system. Okay, one line is going to the system, and other line should go to the relief valve. So here, okay, and this should be connected to the tank. See, you have to connect it to tank. So this type of connection will be very, so many lines will be going through the circuit diagram and all. Normally we won't do like that. We'll have a symbol of the tank. Just you connect the tank, use the tank symbol, and you connect to the tank. Okay, so normally this is being done. Okay, probably on PC and all whatever I have seen, it is that some lines will be going. See, one P line will be going throughout, one T line will be going throughout, or one drain line will be going throughout. So at various points you connect to the P and T connection. Okay, say some line like that you can connect. Okay, in the software we do like this. Okay, at the tank symbol will be there. So it is understood that it is connected into the tank. So here this tank connection I will block. I will block. Okay. So now pressure we have to measure. I'll use a pressure gauge. Pressure gauge I will connect here. Okay. So now there are two pressure relief valves. Okay. One is internally set for 200 bar, and one is the external purpose, user purpose. So that is set for 150 bar. So what will be the pressure expected in the system? When I simulate, pressure expected. So this is how you have to start the simulation. Here now this triangle. So you press here. open connection. Okay, cancel. Here one open connection, tank connection I not given. So this tank can use here. Okay. So now what will be the pressure? The pressure developed is 150 bar. Okay. Because I set the pressure in this through relief valve to 150 bar. Okay. If I set for 175 bar, suppose I change it to 175 bar, you will get 175 bar pressure. Okay. This is how you set the pressure in the hydraulic system. Okay. Okay. One more thing. Okay. Just a question I'll put. One more relief valve I'll use. Okay. One more relief valve I connected to the system somewhere. Somewhere in the system I connected one more relief valve. That I set for 100 bar. 100 bar. Okay. So this relief valve is set for 100 bar. This relief valve is 175 bar. This is 200 bar. So what will be the pressure developed the system?
100 bar.
100 bar. 100 bar.
Yes, yes. See the flow will go through the easiest way. Where is the easiest way? 100 bar spring will be easy to push and open that one. So the flow will go through that. So maximum 100 bar only can be developed. Okay, you can see that maximum 100 bar only can be developed. Okay. So in a hydraulic system, if you use any number of relief valve, okay, but where you have the lowest pressure, that will be your setting. Okay. So you need not connect more relief valves. One relief valve is enough for the user to set the pressure. Okay. So that is how, for that purpose only I have shown this one. Okay, now I remove this one. It's removed. Okay. This one I set for user now setting 250 bar. Okay, user is setting for 250 bar. Okay, without knowing that now the total system is rating is 200 bar. See, that's why manufacturer has made a 200 bar here. Okay, but user now by knowingly or unknowingly now you turn more. The pressure has gone more. 250 bar it has gone. Okay, but whether 250 bar will develop?
No.
No, because manufacturers internally made a relief valve. He set that pressure relief valve to 200 bar. So pressure cannot go more than that. Okay, so that is a safety valve actually. Whatever is inside provided is a pressure safety valve. That is for the safety of the system. Okay, so that is provided. Understood the purpose of this relief valve?
Yes,
Okay,
sir.
and this is for the user to set the pressure. That's how this is required. So this is a hydraulic system. So you can see how it is working. So your pressure is say 200 bar. So you operate when the cylinder will be extending. It moves forward. Okay. So you can see the working.
Sir, difference between relief valve and safety valve?
Huh?
Difference between pressure safety valve and pressure relief valve?
There is a difference. See, normally safety valve is there. When it actuates, it will not come back to the normal condition. When safety valve is operated, suppose something happened, the safety valve is operated, okay, it will not come to the normal pressure. But relief valve is continually sensing the pressure and regulating the pressure. A relief valve will continuously regulate the pressure. That's a regulating valve, pressure regulating valve. Relief valve, pressure relief valve. Okay. When you say exact meaning of pressure safety valve is that whenever it is operated, it will operate. Something happens, it will operate. Okay. Then the pressure will be relieved. Flow will be diverted. Okay. When the system now you want to operate, you have to reset. When you are using a safety valve, you have to reset the valve. Then only again it will work. Okay. So that is actually pressure safety valve. That is the actual meaning of pressure safety valve. Okay. But people tend to use interchangeably. Safety valve or relief valve. Both will be used interchangeably in the industry. But if you understand the difference, it is better. Safety valve, suppose, for example, compressor, if you take. Okay, compressor, your some regulation is there, 6 bar or 8 bar, it is regulated. Okay, but your regulating system fails, what will happen? Compressor will continue to develop the pressure, 8, 10, 11, 12, it will not stop there, no? So there is a one relief valve, safety valve is kept on the tank. Okay, that will open. Okay, the air will be relieved through that. Okay, even if the you switch off and pressure comes down also, that valve will be kept open only. You have to again reset it. Then only again you can start your system. Okay, so that is the exact meaning of pressure safety valve. Clear?
Okay, sir.
Okay. So now pressure control valves. So now I will discuss about pressure control valves. We have seen pressure relief valve. Okay, that is mainly used to the regulating purpose, modulating your power supply. See, pump is giving you flow and the pressure is developed. Pressure has to be regulated. Okay, that regulating purpose. Okay. Now our discussion is whether we can use for control purpose. In system, no, your cylinder control or no some other type of control, no, whether we can use a pressure control valve. Okay, or pressure valves. Such a valve is a pressure control valve. Okay, there are various pressure control valves like pressure reducing valve, pressure unloading valve. Okay, there is a counterbalance valve. Okay, there are many sequence valve. There are very pressure control valves are there in hydraulics. Okay, those things we will study now. Okay, one or two I will take today. Remaining will continue from Friday. So this one, two. Stop sharing. Sharing, no? Share that.
Share, sir.
Okay. There is some problem with that. This itself, two are opened. Okay, two actually opened. Joining meeting. I will close this also. Just now. Leave the meeting.
No, don't leave the meeting. If you didn't leave the meeting, no, sir, it will go to host to other people. Just share, no?
No,
Just minimize.
no, through that only sharing that is gone.
Sir?
Hmm.
Yes, please. Yes, sir.
Okay. So now we'll see the symbols of pressure control valves. Okay. Basically, the symbols will be like this. So there is a normally closed type of valve. They're normally closed. This is closed, and it's coming.
Is it audible?
Yes, yes, sir.
Yes, sir.
Okay.
Unmute yourself.
So there are two types of pressure control valves. One is the normally closed type of valve. Okay, there is inlet is there. Okay, the flow cannot go to the outlet because the puppet is moved away. Okay, there is a blockage is there. Okay, there is a pilot line, dotted line will give. There is a spring, adjustable spring. This is a normally closed type. Okay, then there is also normally open type of valve also. So that is one point you have to note down. Okay, because in your circuit, in Ongc circuit also, they will not write what type of valve it is. You have to by symbol, you have to understand. Okay. So pressure control valves, there are many pressure control valves, all looks like same. Only small difference will be there. So that in order to understand, these are the one point. One is whether it is opened or closed. So this open valve, it will be like this, normally open type. Okay. So you can see the different types of pressure control valves. This is a pressure relief valve, which already we have seen. Okay. This is the pressure reducing valve. This is an unloading valve. There is a sequence valve. There is a counterbalance valve. There is a brake valve. Okay. Except the pressure relief valve, all our other 5 valves are pressure control valves. We can say pressure control valves. Okay. So pressure reducing valve, you can see normally open type. Okay. Remaining all are normally closed only. Okay. These are normally closed. Only open is only this one. So whenever you see a symbol like this, you can be ensured that it is a normally, so it is a pressure reducing valve. Okay. So that way we can identify the valve. Whereas here unloading valve, where is the pilot line here? Okay. Whether pilot line is from the inlet sensing or outlet sensing. Okay. These type of things we can observe and we can find out what type of valve it is. Okay. Sometimes the valve will be controlling the pump. Sometimes it may be controlling the cylinder. Then also we can find out. So sometimes pump control is there. Usually it will be unloading valve. Okay. If cylinder control is there, it may be counterbalance valve or it may be a sequence valve. Okay. Because all these remaining 4 valves are looking like same. Okay. So the sequence valve and counterbalance valve, when you see, or a counterbalance and this one unloading valve, it's coming down. Okay. So it may look like same here. It's coming down. It is coming down. Okay. So it may look like same. Okay. Sequence valve, if you see, this is the inlet going to the outlet. Okay. So the inlet is sensed here. In the counterbalance valve also, the inlet is here. Inlet is sensed by the puppet. Okay. So both are looking like same. Okay. So now it will be decided how it is controlling the application. So accordingly, it will be called as sequence valve, or it can be called as counterbalance valve. So today and or next class now I will be covering those areas. Okay. Then we will be able to say whether it is sequence valve or whether it is a counterbalance valve. Like that, we will be able to say. So this is first one is the pressure reducing valve. Okay. In the pressure reducing valve, it is a normally open type valve. First thing you observe is that it is a normally open type valve. Next is that, okay, next important thing is that it will sense the pressure from the outlet. See, earlier all valves sensing the pressure from the inlet. Okay. See, only pressure reducing valve only sensing the pressure from the outlet. Okay. This is the valve, inlet, this air direction, this is inlet, this is outlet. So the sensed from the inlet. This is inlet here, this is outlet. So it is sensing the pressure from the inlet. Here, this is also like this. So it is sensing the pressure from the inlet. So all valves are sensing the pressure from the inlet. Only pressure reducing valve only sensing the pressure from the outlet. So 2 things are there. Okay, one is the normally open type and pressure is sensed from the outlet. Then that is we can ensure that it is a pressure reducing valve. Its purpose is to reduce the pressure in the outlet. Okay, inlet pressure may be higher, but outlet pressure will be less than that. Suppose this 100 bar, outlet pressure at A is 100 bar, I want to reduce the pressure at B to 50 bar. That is possible through this pressure reducing valve. Okay, you can set the spring tension to the corresponding to 50 bar. So when 100 bar is coming, okay, it will be coming out. That output will be sensed, and it is acting on the puppet. Okay, when the 50 bar is reached itself, now it will operate. It will close the valve. Okay, so it will not allow that pressure to increase more than the set value. That is the pressure reducing valve. If pressure less means it will open. Okay, again it will develop the required pressure. Okay, so by the opening of this, the here orifice here, okay, this control is here. So the pressure will be controlled at the outlet side. That is a pressure reducing valve. Okay, it can be pallet operated type also. Okay, okay. Now what is the application of this? Suppose in a hydraulic system, okay, you want to have a clamping pressure of 50 bar and a punching pressure of 100 bar. The same circuit, you want two pressures. Okay, one is 100 bar and one is 50 bar. 100 bar, 150 bar. Two pressures are required. Okay, if we are using one pump and one relief valve, say one pump and one relief valve, okay, when 100 bar is set, everywhere the pressure will be 100 bar. Okay, so in that case, you can have a pressure reducing valve. You can have a pressure reducing valve connected. Okay, so this set for 50 bar. Okay, so you have the pressure at the outlet from this side. You have the cylinder B. Pressure will be 50 bar. It will operate at 50 bar. Whereas the cylinder A will operate at 100 bar. So that is one solution. Okay, in this way we can have two different pressures in the hydraulic circuit with one pump system. Otherwise, you should have two pumps. Two pumps you can use. Okay, one pump is one relief valve set for 100 bar, and another pump you use another relief valve. Okay, these are separate. There is no leak. Okay, only maybe the drive shaft may be common, but pump circuit will be different. So you can set a 50 bar in the second pump, and that way you can get the operation. Okay, so we have to see the cost for the two pump buying or this one. Okay, buying one pump and one relief pressure reducing valve using that will be better. No? Comparative study you can do and you can decide. Okay. Sometimes what happens, you have to take the flow rate also. Okay. Suppose you need 100 LPM in one circuit and second circuit only 10 LPM required. Okay. Then by using reducing valve also, you may not save energy. Okay. You have to use two pump also sometimes. So one small pump and one large pump. 100 LPM and one 10 LPM. So small pump, you can set whatever pressure you want, you can set. So sometimes that will be better. Okay. But the flow rate, not much difference. Say one is 10 LPM, another is 12 LPM. Okay. Then there is no need of two pumps. One pump only, one pressure reducing valve you can use. Okay. So you may find number of options in the designing time, or you may find in a circuit, a different way, circuit is being developed. Okay. Now I will show some circuit. That is gone. There.
It will be there, sir. Just you share, sir, whatever you want. No need, sir. Live only you can do. No problem. Here.
Stop sharing. Let's see.
Listen, sir. Share here.
This
That is pressure relief one has come. Reducing one has come. See open, sir. First.
here.
Open. Share.
No, it is not. This only.
Here, if you go on the top, here, sir. Here.
Yes. So you can see the circuit diagram here. Okay, there are two circuit diagram actually. Okay, one is the with a pressure reducing valve. So the pressure is 100 bar set. Okay, this pressure is 100 bar. You can see 100 bar is set here, and this pressure reducing valve I set for 50 bar. The 50 bar. So one pump only I am using. One pump is used. So this 100 bar is going to the downstream upstream of the here pressure reducing valve here only. Okay, this side only you get 100 bar. Downstream of the pressure reducing valve you get 50 bar. Okay, you can see here. Okay, so here the system works at 100 bar. Say this cylinder working at 100 bar. Okay, when this cylinder is moved, it is working at 50 bar. This pressure is 50 bar. Okay, turning back, this is 100 bar. So like that, now two different pressures are required in a hydraulics system. You may use a pressure reducing valve. Otherwise, you have to use like this, two power pumps. Okay, or one pump, one power pack, but two pumps will be there in that. In the software, it is difficult. I made two power packs. Otherwise, one drive, two pumps will be there, and it can be supplied. So this is 100 bar. This This is set for 100 bar. This is set for 50 bar. So this also will work in the same way. So this is working at 100 bar. This pressure is 100 bar, and this pressure will be 50 bar. Okay. So there are two options. Okay, when you are using, you want to use you want to have two different pressures in different parts of the circuit. Two options are there. Either you can use two pumps or you can use a pressure reducing valve. Okay, you have to analyze further properly, and then you may be able to take a decision whether to go for a pressure reducing valve or a two pump system. Three also. Suppose three pressures are required. You can have three pumps or two relief pressure reducing valves. Okay, so like that also you can have. So one is 150 bar, another is part 100 bar, another part 50 bar. Three different pressures are required. Then also it is possible. So this is a pressure reducing valve. Okay, next we'll see the unloading valve. The symbol is also there. Okay, the symbol is unloading valve is here like this. Okay, it's like a pressure relief valve only. In pressure relief valve, this pilot line, now this will be connected to the here A. When it is joined here, it is almost like a pressure relief valve. Okay, but this is separated out. Okay, this is the pressure connection pilot line which you have to connect to some part of the system. Okay, where you have a static pressure. Okay, when you have a static pressure, that point you can sense the pressure, and this can be kept opened, and the flow can go to the tank. So that is how this is working. So this is the unloading valve. See, normally when you say unloading, what you are going to unload? It is the pump. Okay, normally unloading means pump unloading. The pump flow should be diverted to the tank. You can unload through the relief valve also. You can unload the pressure through the relief valve also. Okay, but unloading valve, when you relieve, they are also relieving only, pressure relieving. But there is some difference between the relieving through the pressure relief valve and relieving through the unloading valve. Okay, so this is unloading valve. So here you can see there is a hydraulic system here. This is a pump is there. This is unloading valve. This is unloading valve. Okay, where this line, pilot line is taking the pressure from this part of the circuit. Okay, so this is the line where you have a static pressure. Okay, there is no flow. So when this is closed, when the check valve is closed, you have a trapped pressure here. That pressure is operating this unloading valve and keep it opening, so that the pump can unload easily through this unloading valve to the tank. Okay, it did not do any work against the spring. Okay, so if you see the relief valve, okay, this flow is coming and this pressure now acting here on this, continually working against the spring. Suppose this is 40 bar is there. So against 40 bar it has to work. This oil has to work against 40 bar continually, keep it open, then the flow output will be coming. Okay, so continuously it has to work here. The pump has to work here. Pump has to work here. Whereas here the pump has to, if this valve is opened, pump will just pump out through this valve. Okay, it will leave through this valve because pump has to do no work. Okay, it has to do no work. Okay, first it will go, the flow will be go, and the cylinder will be extended. When it is fully extended, okay, I release this one. The valve will come to the center position. It will be get closed. This is a close. So this part will be closed, or we can say this part will be trapped. The flow will be, or the oil will be trapped here. High pressure oil will be trapped here. Check valve gets closed. Okay, because the pump will see an easy way through this one, through the unloading valve, and the flow will be going to the tank. Okay, at that time the pressure, there is no opposition to the flow. The pressure in this line will be very minimum. Not at 40 bar, not okay. It will be very minimum pressure will be there here. So pump is just pumping at a minimum pressure. So the energy involved or power involved will be less. What is power? Power is equal to pressure into flow rate. Okay, P into Q. Okay, if P is very minimum, okay, say 0.5 bar. Okay, you are maybe 100 LPM. The minimum power will be involved. Minimum pressure loss will be there. Okay, you can save the energy. That is the idea of this unloading valve. Okay, so here both are there. Unloading is there, relief is there. Okay, usually it will operate through the unloading valve. If anything happens to this only, this will open and this relieve at a higher pressure. Okay, I will demonstrate through the simulation software.
Share. Yes. How to select this?
No, this is fluid sim I opened.
Share, share.
This come. So this is a fluid sim circuit. Okay, the pump is there. There's a PRV. PRV is set for 300 bar. This is the set for 298 bar. So the system should work at 298 bar. Okay. So I reduce the pressure to 298 bar here. Okay. Here I am using a check valve. Okay. Check valve will allow the flow in one direction only. So flow will go into the system. It will not come back. Okay. So if any pressure is there, that pressure will be trapped there in this line. So this is the place where you get a static pressure. From there, I am taking the pallet line. Okay, the pump will not do any work. So when it becomes static, the pump will not do any work in operating this unloading valve. When this is opened, pump will see an easy way to flow. With minimum pressure will be there here in this line. Okay, so we'll see this one. Okay, say now I'll remove this pallet line. First, I will remove the pallet line. Pallet line is not there. It's not connected. It's not connected. Okay. So now what will be the pressure developed? We'll see. Okay. So now the pump is pumping the oil, and so this is working. At 300 bar, it is working. Okay. This 300 bar is working. Cylinder is also working, but the system pressure will be 300 bar because it is working against the pressure relief valve. This pressure relief valve is there. Okay, this is spring tension is corresponding to 300 bar. So the pump is working against this 300 bar. It is doing work. So what will be the total power developed? Suppose P is 300 bar. The flow is displacement 1.6. So 1.6 into 300 by 600, that much power will be involved here. Okay. Now if I use a unloading valve, what will be the difference? See, I connected unloading valve. Okay. Now what happens? The pump is pumping, so this becomes trapped. So it will work. This will still work in the same way. So when I put back, what will happen here? What will be the pressure? The pressure is very minimum. The pump is pushing the oil through the unloading valve with the minimum resistance to flow. Okay. The minimum resistance to flow is reflected as a pressure. More resistance, more pressure will be there. Okay. So there is minimum resistance to flow. It is flowing through the unloading valve. Okay. So what will be the power involved? 1.33 into that 1.6 into divided by 600. Very minimum. So 300 to 1.33 bar. Just reduced. Okay. The pump will just unload, just pumping. Okay. Pump take the oil from the tank, push it to the tank. Okay. That way unloading valve will be working. Okay. There is a difference between relief valve working and the unloading valve working. Clear? So this is the idea. This is generally used for accumulator circuits. When you have an accumulator here, accumulator gets charged. Once it is charged, that pressure is operating the unloading valve, and this get opened. Okay, that pressure will be static. It will not flow. It will not go anywhere. It will be in that line only, trapped. So that pressure will hold open. That will hold open the unloading valve, and pump will see an easy way to flow.
Sir, how much time it will get static? Like
static, see, when I am operating, this is immediately static. This is a real time. Okay. So you are operating that time, immediately it is starting. Generally, see, you will not use unloading valve when there is a very high frequency operation. See, you are operating cylinder moving like this, cylinder moving like this. Fast operation is there. You will not use the unloading valve. When you use unloading valve, when you have a, suppose you are clamping, no? Suppose something you are a big job, clamping for 1 hour. Something you are pressing for 1 hour. Okay. So now I will give a signal. So it has to be pressed 1 hour. Okay. Why the pump should work continuously? Okay. Even if possible, you can switch off the pump. Suppose only one pump is there, you can switch off. If multiple pumps in one drive shaft, you cannot switch off. Then you will use an unloading valve. Okay, 1 hour it will just go like this. There is not much of energy loss here. Okay. So always we will not use unloading valve. Okay. When a long operation is there, that is the fit place for using unloading valve.
No, sir, which like how much time it will be like static only, like the 298 bar is will be how much time it will exist like static? The pressure will once upon a time it has to get reduced, right?
Huh.
It
How
cannot
much
be
time is
static for a long time.
static? No, see, when because of the check valve, see when we start unloading, it become this check valve will close. This side pressure is more, this side pressure is less now. So check valve is closed. So that here it becomes like a static.
Sir, that static, how much long it will like
As long as you are
get
not
static?
operating now, it will be like this. Suppose in the operation, you are holding for 30 minutes. It will be like this only. It will be like this. Suppose in the application I'm telling, the operation application, something you want to operate and hold like that for more time. Okay. See, compressed wood, no? Compressed wood. How they are manufacturing compressed wood? It will be pressed for 3-4 hours. Hydraulically, it will be pressed for 3-4 hours. Okay. And you will have a number of multiple pumps are there. Okay. One pump has to unload. Okay. One pump, we controlling some 6 cylinders are there. It is operated. Okay. And then it has to be pressed for 4 hours. Okay. So you cannot use a relief valve. Then lot of energy will be lost. Maybe 1 hour itself, 3-4 units of energy will be lost, electricity. 4 hours if you press, lot of energy will be lost. Okay. So if you use an unloading valve in that circuit, you save a lot of energy. Okay. Here itself, 4.79 into whatever the pressure here in the flow, 1.6. 1.6 into 4.79 divided by 600. Maybe some 200 watt something, that much power only involved here now. Very less power. Into the time will be your energy. Okay, power into time is energy. So how much unit of electricity will be consumed, that will be decided by that. Okay. So this is unloading valve can be used in such applications. Not always.
Sir, please place that.
Relieve. Sender.
Sir, keep it in this position.
Right
now, what I'm asking is this line which was static, where the pressure got.
Okay. Understood. So here in the software, I shift and press, it will be like this. Shift and if you press, it will be closed. Here it is, that also not required. You can bring to the sender position. Sender position is also closed sender position I am using. This will be blocked.
And now in this line, how much time, how much long it will get static pressure only?
Static pressure only. Yes.
No, sir, how much long it will exist like static only?
I think you are talking about the leakage.
Not leakage, sir. What we call?
If it is a tightly, there is no leakage. Zero leakage means it will be there as long as you put like this. This pressure will be remaining as long as you are not operating this one. 1 hour you are not operating, it will be like this.
Actually, means till the time we don't operate, it will be the same
like
pressure.
Yes. See, in the pump side, you have the pressure will be less. Whereas in the application side, you get 298 bar.
Okay,
So,
understood. Sir.
pressing, no? See, the pressing will be at 298 bar into area. That force will be developed. Understood, no?
Yes, sir. Yes, sir. Understood.
Whereas pump, as far as pump is concerned, we cannot stop the pump. Suppose we are not able to stop the pump, but it is pumping to the tank. It is just pumping to the tank. No work is done. Energy consumed will be less. Followed. Okay.
Okay, sir. Okay.
You are not going to use unloading valve always. In all hydraulic circuit, you will not find unloading valve. Okay. Some typical application. One is the, as I told, one is the accumulator circuit. Typically, accumulator circuit, we are using the unloading valve. Say accumulator charged, say some operation will be done. Accumulator charged means then that pressure, static pressure, will be acting on the unloading valve, and the pump will see an easy way to flow. It will just unload. Followed. Okay. So your pressure, when you start unloading, easy flow means the pressure will be reduced here. Okay. If that is not there, suppose this line it is not there, you will find 600 bar. 300 bar. Okay. So when you operate and bring, you will find the 300 bar here. Now pump is relieving the pressure through the relief valve. Because I removed this line. Unloading valve, no? Pilot line I removed. Now the energy or power involved will be 1.6 into 300 by 600 kilowatt. That is the power involved now. Followed. Into the time, how many hours you are operating, that much energy consumption will be there. Okay. If using an unloading valve will be a better option. In this case, using an unloading valve will be a better option. Unloading valve connected. Now if you operate, your pressure will be less. You get the same operation. See, operation is 300 bar or okay, some 1-2 bar you have to reduce here. Or you make 300 bar here, 302 bar you adjust. So, so that way it can be done. So this is the how this is unloading valve is working. Okay. See, what you have to understand. Say you have to make a static. You have to use a check valve. This is how normally we do. A check valve will be used. Okay. The downstream you take the pilot line. Upstream you take the pump connecting to the unloading valve and going to tank. So this you have to connect. Pressure pilot line is taken from the upstream side of the downstream side of the check valve. It is taken and it is holding the check valve open, actuated. So it will keep it. It is opened. Come. See here the applications of unloading valve you can see. Okay, so this is a check valve. So pump, the pump flow will be going to the tank like this, and this is the pilot line is taken like this. This is some company. This one they are manufacturing this type of valve block. See unloading valve plus check valve block they will give. This is the drain connection. Dotted line is a drain connection. Okay, if any oil is coming to the spring chamber, that should go directly to the tank. So there will be P line, T line, and drain line. The drain line. So this is a model, one model of unloading valve supplied by the company, and this is the other one. Here the drain line is connected to the tank. That is no problem. Okay, if back pressure and all no issue, then it is you can use this valve. Okay, otherwise the drain line suppose any oil is there in your spring chamber, your pressure setting will change. Okay, any leakage, the spring chamber oil fills, then your setting will be changing. That's why this drain line is required. Usually, separate drain line will be there going to the tank. That way. So this is another way it is there. Another way it is there. So usually this is the unloading valve circuit will be like this. Okay. Or one more circuit is there, that is called the high-low circuit. Okay. There is a high-low circuit. Okay. That I will explain tomorrow. High-low circuit. Okay. High flow, low flow. High flow, low flow. Okay. This circuit also using the unloading valve. Okay. Tomorrow I'll explain this one also. Okay. This is a double pump system. For this you are using the unloading valve. So next sequence valve, then counterbalance valve. So like that valves are there. Okay. Tomorrow we will continue from this. Okay. From this onwards we will continue. Okay. Today we will make a stop. Okay.
Anybody is having any doubts, please ask sir. Today's topic. Sir is leaving now. After 5 minutes, I will continue the class. But any doubt before going, sir will clear all the doubts. And tomorrow morning again, sir will continue the class.
Friday.
Sorry, not tomorrow. Tomorrow is holiday. Friday is taking the class. Is it okay?
Yes, ma'am.
Hello?
Yes, ma'am.
If doubt is there, please ask sir.
Sir, please differentiate once again, sir, between PRV and safety valve, sir. Relief valve and safety
There is
valve.
a difference, sir.
Yes, sir. What
Okay.
is
Okay. See, normally pressure relief valve, when say when the pressure is suppose you set for 200 bar. When 200 bar is reached, what will happen? It will open and it will relieve the pressure. When pressure is going below the 200 bar, again the puppet will close the relief valve. Okay. So continually it will open, close, the regulation will be there in the pressure relief valve. Okay. The exact meaning of pressure safety valve is
Sir, you are not audible, sir. Hello. No, sir, you are not audible.
Some internet connectivity issues are there.
Your network, I think, is not.
some.
Yes, sir. Now you are audible, sir. Please continue, sir.
Okay.
Some delay is there, I think. Okay, now audible?
Yes, ma'am. Now audible.
Okay. So there is only a subtle difference, very minor difference only between the pressure relief valve and pressure safety valve. Okay, pressure relief valve we have seen already. You have seen. Okay, it will always continually regulate the pressure. But safety valve, once it is actuated, operated, it will not come back to the normal position. Okay, see, because something fault has occurred in your system. Okay, that's why the safety valve has operated. Okay, you have to clear the fault in your system, and then you reset the safety valve. Then only again it will be working.
So in generally, sir, the safety valve means safety valve rating is higher than the pressure relief valve rating in system.
Yes. Usually little higher 10, 20 bar. You can set a higher level. You can set. Okay, not the same pressure, system pressure. Little higher pressure, 10% more pressure you can give, and you can set the safety valve. Suppose in case this fails, this relief valve fails or something, the safety purpose it is used. Okay, but once it is see what is the actual meaning? Once it is operated, okay, the normal way it will say you have to clear the fault. So what fault has occurred, you have to find out, and when that is cleared, and when you some lever you pull back or something, again you have to bring it back to the normal position. Automatically it will not come to the normal position.
Okay.
Clear, no?
Okay, sir. Yes, sir.
But
Thank you.
what are you to
Sir,
understand? In the industry, people will interchangeably use the term. They use a relief valve, they say safety valve. Okay,
Yes,
safety
sir.
valve, they say relief valve. But once you understand the difference, the context you understand enough. But
Yes, sir.
the
Now
textbook
the
meaning I am
difference is
telling.
clear.
But the
Yes,
industry, when you use, be very careful, because they use a different, without understanding, they'll speak. Okay, the operator or something, they may speak they don't know the function or meaning of that. Okay, they say some name, but we should understand the clear meaning and whether the exact purpose is it is being used, that we have to understand. Okay.
yes, yes, sir.
Yes.
Excuse me, sir. Usually we use both the walls PSV and PRV, or is there some guideline that you have to use one
PRV?
or PRV and PSV? We
PSV.
use both, we use both the walls
Both the
together.
walls, that depends upon your safety concern in your organization. See, some other system may not be that much safety concerned thing. A relief valve may be sufficient. But in ONGC and all, suppose somewhere offshore, some safety may be very critical.
Right.
Okay. Or something, chance of failure more, then it is better to have a safety valve. Additional measure to get a safety.
So in this case, sir, the safety wall is set at what point, or at what pressure, and relief wall is set at what pressure?
No,
Or
see, that's what actually exactly I don't know, but that's why I told just 10% of the system pressure. More that you have to set. Suppose 100 bar is there, you can set the safety valve 110 bar. Some 10% is something like that. Or
and,
if
and what about the relief wall, sir?
relief valve is you are setting in the design, you are finding now what is the pressure, what is the flow rate, you are finding now.
Right.
The design to get that work operation. Suppose some 5 kilowatt work operation is there. To that, how much pressure, how much flow rate, now we have to find out.
Okay.
Can be a long, you can say, a number of options will be there. Pressure
Right.
setting in hydraulic system. In pneumatic only 6 bar you are setting. Normally. But in hydraulic now, same system will work at 50 bar or 200 bar, 250 bar, 300 bar. Okay. One designer can design for 300 bar. One designer can design at 50 bar. It is possible in hydraulics. Okay. So that is the options are more, but you have to go for the optimum design. Okay. Optimum design you have to make. So that is a little more involved topic. Okay. How to decide the pressure and all. Okay. There is a more analysis you have to do, and which is the best cost and effective thing now. So that you have to find out. But suppose 10 designers are given the work, 10 designer will give 10 different pressures. It is possible. That is a difficulty in hydraulics. Pneumatics, no problem. Almost 6 bar, around 6 bar you are setting pressure. So easy to design. Okay. In manufacturers also offering components works at a different wide range of pressures. Okay. So I cannot say now what is a particular pressure to be used. Okay. So normally industry up to 350 bar. In outside turnkey projects and all, there are 700 bar systems are also there.
Okay.
But majority below 210 bar is used in industry. Maximum around 100 to 210 bar. Majority of the systems are set, the pressure setting is done between 100 to 210 bar in industry. When a large work operation is there, 350 bar, up to that we will go. Heavy load, when very heavy load is there, it is better to go for higher pressure. Okay.
Is it clear?
Yes, ma'am.
Yes, ma'am.
Shall we tell thanks to sir to taken the class for so long from morning to here. So after 5 minutes we'll come back. If you are not having any doubts, we'll take a small break, 5 minutes.
Yes, ma'am.
Okay.
There is a disturbance, ma'am. There is a disturbance.
Hello, is it clear now? The voice is clear?
Yes, ma'am. Yes, ma'am.
Okay, okay. Now I wanted to take some small feedback from a thing morning. How was the class and what is the difficulties you faced? Morning session was a little bit this thing. Later I think it was cool. So is it okay for you?
Yes, ma'am. Absolutely fine.
Okay. Can I hear all of you some feedback? How you want the next sessions to be continued from our guest faculty with some like a feedback? I want some videos if you want to share or how we want to do, because we are having only one day. That's why, as per your feedback, tomorrow is a gap for us, so we can prepare some more things and we can come back with the things. Tomorrow I will check my drive. Some problem in the net issues, so it was not getting that yesterday. So tomorrow I have a gap one day, so that I will prepare all the material whichever is required for you people. So please, all of you speak out.
So, ma'am, mainly some animations, videos, and if possible, practical demonstrations possible.
Okay. Okay. Yes, I can understand that. By showing some videos and animations.
There we are not able to see exactly how it is. No?
Correct. Exactly. Even I was thinking same thing. Tomorrow I'll connect some videos and everything. I'll say sir also to bring some more videos, which is overall completion of the course. So if you say which animations, which particular topic, we can concentrate on that. Is it any particular thing from there?
Various types of valves which we have been discussing since yesterday.
Okay.
If certain examples are given which are related to oil and gas sector, so that we can easily correlate, because we are mainly working on fields, and it will be helpful for us to correlate, and later on when we go back to the field we can understand the things better.
Yes. All of you, please give your feedback. I'm writing it because tomorrow I have a gap and I'll work on that as much as possible. We'll get, because we have a Festo trainer kit. They have given some of the materials. If I, for example, sir showed one license thing. Correct, na? Have you seen that license simulation? Have you observed that whatever yesterday I have given, it is much more developed today? Have you observed, all of you?
Yes, ma'am.
Yes, ma'am.
That is the latest one. That is a license version that we cannot share you. That's why I showed you the demo one. So in that, some of the materials are there. I've collected it because in the this one also some network problem, so I couldn't put it in the drive. Tomorrow I'll work out on that. I will put it all the materials over there. So particularly if you give that, I can write it and I can go for the better thing. Like today, I think animation has on the pump, it was clear. Correct? Is it?
Yes, ma'am. Yes, ma'am.
Yes,
Walls and animations. Correct, na? Then next.
Ma'am, you told like you can visually see how the lube oil is passing through this wall.
That video is there. I will play after this thing. After this power pack, after reservoir, after taking the class, I will play that. So I can wanted to explain some of the things. So I will do that today itself. Okay.
Ma'am, on the last day, if possible, half of the day can we get for the whole revision? Can we get back again?
Yeah. That will be done. Okay. Like we cannot do so much. You also know sometimes the net also is not cooperating. The issue with the communication. Sometimes we plan so much. Actually, today sir has planned so much, but the whole day has went without only pump has covered. Correct, na? Sometimes we
Yes.
cannot go for the last moment. That's why I request you people. If you say that some of the things which is videos and all I can share, whichever the very important things I can do it in the class Friday.
If there is something specific which you want faculty, that would be better if you point it out. Or we can do the revision part after, like, in the last day. The second half can be done with the revision part. So it would be
But
better
the
if you point it out.
second half, have you seen that schedule? The maintenance part, sir is taking. Another sir is taking. So I cannot tell them to do the revision. So it is better that morning session only will do the revision plan. See, you can see that schedule is case study and maintenance that has handled by our another guest faculty. So that's why tomorrow morning, Friday morning I can do the revision little bit. Is
Okay,
it okay?
ma'am.
Okay.
Yes, ma'am.
Okay.
Yes,
Okay. Then you asked me that walls and animations. Next, particular anything which you are facing problem in your industry, like any particular thing. Other people, please speak off. Is it how was the class today? Pump the sir has taken. Animated also he has shown many things. Is it clear?
Yes, ma'am.
Yes,
Great
ma'am.
classes.
Class was very good.
Bleed wall. I want to know about bleed wall.
I asked sir today. He told today he will prepare and come. Actually, sometimes it is locking. The air is locking. Or air or oil will be locked. For that hose pipe or wall, we have this type of setup. I'll show you just. I will show this. I will show on the Friday. There will be locking type of things. We have to remove that whatever the locking, gas leaking, the trapping of the air or oil. It has to be released because otherwise it will create a back pressure. Because of that, he told the bleeder valve will be there. It will be opened, removed like this, and it will be taken out the trapping. That's what he will work out today. He will bring some of the more things. Is it okay? I'll come back, again I'll come back. I've written and given to sir, leader wall.
Okay, ma'am.
Remaining anything is there related to that? Have you, all of you worked on the fluid sim? I told you to work at least one circuit and post me in the group. Nobody has replied.
Ma'am, it is not supporting.
Not supporting. You cannot work on this.
The drive which you sent is not supporting in our PCs.
What is it exactly saying, sir? Like, what is the issue it says when you try to download it?
It was supporting in Windows. I think
Okay.
it was using iMac something.
Oh, okay. So the software is not actually available for Mac OS, sir. It's only available for Windows, which we have with us. We don't have the demo version for Mac OS.
Actually, I downloaded it in Windows itself, but it is not supporting.
What is it saying, sir, exactly? What's the issue it says?
Like, like it will directly say it is not getting supported. That's it.
Okay, we'll try sending you the software once more and then we'll.
No, I'll separately that only that folder, whatever the fluids in there, that will I'll send it in your mails. Okay. Tomorrow I have the time, so tomorrow I will work out for that. Okay. Okay. Shall we continue with the? Yes. Tell me, ma. Somebody is speaking something. Shall I continue?
Yes.
Okay. More? Can I continue the class half an hour more?
Yes, ma'am. No problem.
Yes, ma'am. Yes, ma'am.
Yes. Continue this. This was the topic yesterday. I wanted to complete this topic. So we have here power pack. Now we know that this is the one which we call it as a hydraulic reservoir, our power pack, or whatever the content like. It may looks like this different type of shapes in your usage area. Okay. Now what it contains is, here it is having a first, that is the whatever we have filter, that we call it as a offline filter. Then we have here the level indicator. Oil will be filled in the tank. It is a intake return line will be there. Then level and temperature sensors are there, because it may be we have to indicate that level plus whatever the temperature it is giving. Then air breather will be there, small air will be there, should be go for the ventilation purpose. And cooler also is there. This is a one ideally type of hydraulic reservoir. If you go inside, it contains a container. It stores the sufficient quantity of fluid. We have to work out for this much quantity for everything. It will have a sufficient quantity of the fluid. The reservoir serves as a storage house and a liquid and a fluid container. This is the container. Here, the serves the fluid before it pumped back to the system. This is like a container type of storage thing. Allows a reasonable welling time for the fluid. Welling time means when allows for some time. For example, it is working on the fluiding pipelines. That is called welling time of the fluid. Allows a reasonable welling time for the fluid. Allows enough time to contaminate it to drop out from the fluid. So before some enough time will be there. For example, a fluid will be having the span of lifespan which is 4 years, 5 years or something. For vegetable oils, or will be having lesser than that. Like this, some of the whatever before going to contamination, it will be the time lifespan will be contained in this reservoir. Compensate the volume changes. It will be whatever the compensates for this volume changes. It will take care and it will give all the indications that further it will be safely can be proceeded. Act as a heat exchanger, facilitate cooling and hydraulic fluid. We have here sensors and also coolers. It will it will take a time to keep cooling and it as acts as a heat exchanger. And whatever the temperature comes in the season wise or in the systems, everything can be exchanged here. It keeps in a particular one temperature, which is a set pressure. Now, standard features of the reservoir. A well-designed reservoir should be completely enclosed and self-contained. So it should not have any dirt particles or it should not have any leakage thing. So it should be closely enclosed. Right? The shape is sometimes it is rectangular, sometimes it is cylindrical or T or L shapes. The inside the surface must painted with a rust inhibited paint. So because of corrosion, we have to paint it in a good quality of the painted so that it should not get rusted. The material, it is whatever we used is mild steel, stainless steel or with whatever the metals which have alloy, like aluminum, polythene, like that. Some alloys also mixed in that, so that the material will be having more sustaining for the corrosion. Now we'll be having a polyethylene with no seams to leak, no rust, and no welding flats to breed the contaminations. This is one of the materials property that will be having a better protection for the corrosion. Now next, when we go for it, it should be well designed reservoir, should be completely enclosed and thin, shape rectangular. You can see here, it is containing constructional features. It is containing a buckle plate. Can you see here a buckle plate? The picture is clear? Okay. Now it is here, whatever we are having here, this is a cross section of that. So here we are having input and suction lines. You can see the parts. Is it clear? This one is a cross section of the cut section of this. Here the end plates. This is a buffle plate. This is a drain plug. Here we have a strainer, and here we will be having a temperature or sensor which is giving for the indicators. And here we are having a plug-in type of drain plugs, and other things will be having a return line, drain line. Here the inlet and air breather. Like this, the cut section of the hydraulic power pack will be there. If you go inside this function, buffle plate, what is the function of a buffle plate? Constructional feature. Buffle plate fitted lengthwise through the middle, size with the height and 70% of the maximum of the height of the fluid. It should be containing more than 70%. The bottom corners are cut diagonally to give sufficient openings at the bottom for equalizing the fluid levels on both the sides of the buffle plate. Because buffle plate makes the whatever the equalizing the levels, it has to be done in this type of corners. The purpose of buffle plate is to separate the suction chamber to the return chamber. The buffle plate is the one which makes the difference between this, and also it is a purpose for this for the filtering also. This assists the releasing the heat and air and settling the contaminated. It also works as whatever the settlement with some dust particle there, it should be settled down with the contaminated heat exchanger, and also it gives a breather which air can be circulated inside the thing. It also assists for this all these functions. You can see here a idle. For example, this is the one which is having a rectangular shape. You can see an indicators are here. You will be having on the time a cooler will be fitted, suction lines. The tank should be preferably have a separation between the inlet and the return line. This avoids the fluid emulsion and introduction to the air into the hydraulic circuit. This is the one which is having the tank where we are going for this all type of buffle plates inside, and whatever the will be having the separation between the chambers. Ensure all the suctions is not from very bottom of the tank, so that protect the pump from any dust particles. So some dust particle or deposits, something particles are there. We should ensure that a suction is not from the very bottom of it. Little bit upper should be placed. Next, when we go for this, suction line carries the fluid from the pump inlet. Suction line usually fitted at the suction strainer or filter. You can see here, this is the oil diffusion from this. It comes here and it goes to the buffle plate, and again it will be comes out from the thing. So inlet and outtail, in between the dotted line shows the diffusion with the buffle plate. Then it will be having the circulation shown in the figure. The return line carries the exhaust fluid from the system back to the reservoir. From the return line has to come, and it has gone from the back to reservoir. Now, made up of two concentric steel tubes with the inner surface discharge tube and reduces the velocity of return line. The return line velocity should be reduced just before it is entering to the reservoir. Otherwise, it will be just when it comes inside, the whatever the contaminated settle down in the down, it may again it will be flown to the top. If it is the speed is increased, it may come in the forcibly to the depth, and the dust particle contaminated whatever it will settle down, it may come up again. It will be mixing of the with our return lines. So to reduce that, we have to reduce the velocity of a return line. Diffuser reduces the aeration, foaming, and turbulation and noise caused by the return lines. All these diffusers will be kept to reduce this whatever the foaming or turbulency and noise which is coming from the return line. This is the purpose of this diffuser. Now when I go for this, again some accessories. We need some filter cap should be there, breather will be there, breather should be there for the ventilation purpose, and otherwise moisture will form. Moisture will form, again it will create a contaminator of water. So that's why some small type of caps will be available, filter cap with the breathers. Then also that also can be given. A reservoir level temperature gauge. Here we are putting a temperature gauge to safeguard that the oil or whatever this should not be heated up. Once the temperature increases, it will adversely affect the viscosity of the oil. That's why we have to take that. It should be having a, we will go for the temperature caretaking. So here suction strainers will be there to give that whatever the things are there, it should be contained by the different type of suction strainers. It will be having one or two suction changes. Maybe it is maybe increased depending upon the your length and size of the things. One or two suction strainers will be given for the inlets. So now filter breathers. An opening of the top of the reservoir that acts as a filter cum breather. This opening can be used for refilling of the fluid into the reservoir. That also you have the cap will be removed, and whenever we need the oil, it can be refilling. This opening can be used for breathing air in and out of the reservoir as the volume increases, volume inside the reservoir changes. This has to be given for the volume inside the reservoirs. Now, an air filter of 5 microns or better. This lesser the things are there, that will be better. If you go for 10 microns, 15 microns like that, the cost below 5 microns, if you go, as well as the cost also increases. For example, if in pneumatics or hydraulics, which place you are using, that makes more difference. For example, if you go very hygienic conditions, very like food processing industries or anything, that time you have to see that the system should be very safeguarded with a very hygienic condition. If a JCB is working on the road, we need not to go for more type of filters and the things. So 10 to 15 microns. In pneumatics, we'll go for 50 microns. That's all. The filters will be having, it will be having the buckle plate where the filters are connected with the 50 microns. If we go for more than, means for example, we reduce the time of the filters, it may cost, the system may go costly also. That also we should take care. The air filters up to 5 microns is better, is incorporated for the breather to prevent the airborne contaminated or moisture from the reservoir. Whatever it is there, the shape you can see here, this type of things will go with the better working purpose to avoid the moisture or for the different type of contaminants. Air reservoirs, we have different type of level indicators. Level indicators can be monitored by incorporating the site windows. We can see from the outside, we can see the levels, and we can come to know that oil level is decreasing or increasing, or it may be, this is a precautionary measure. These level indicators and sensors are kept to give the precautionary signals. We have to go for the maintenance purpose. Fluid level.
Some disturbance is there.
Ma'am, actually it is running in my PC now, the drive folder.
Sir, please.
Ma'am, disturbance is there.
Hello?
Yes, ma'am.
Sai Kumar, is it working? You are that fluid sim?
Yes, ma'am. Yes, ma'am.
Okay. Good. Okay, then you can share that only folder to your friends. Let them work out. Okay. Again, I'm sending some more things. Today, whatever the sir has taken pump, I will share to you. That animations, PPT, everything I'm going to share you. Okay. By the time of evening or tomorrow morning, I'll definitely share all the material. Okay. Is it clear?
Okay, ma'am.
Voice is clear now? Okay.
Yes, ma'am.
Okay, I'll complete this within some few PPTs are there. I'll complete the class. Give me 10 minutes. I will complete the class. I'll complete this topic and I'll go for some more this thing. Okay. Now, level indicators can be monitored incorporating the sight windows and fluid level indicators and level gauges. The sight window can be used to quick visualization for the visual inspection. It should be have a window for these indicators or sensors so that it easily can be visualized and you can be taken a very good step in before any problem comes. So it is always given in a transparent type of windows where it is all the sensors and gauges are fitted. A transparent fluid level indicator can be used and in integrated level indicators such as dipstick or floating can also be used. Wherever we have better facilities, that also can be included into this thing. Now, next we come back to these suction stainers. Submerging the stainer can be incorporated in the pump inlet line to prevent dirt, grit, sludge, rust, etc. from entering to the pump. These are the stainers. Stainers are filters. In the suction lines are there. In this avoids all type of dirt or grit or sludge. Sludge means somewhat we will be having the precipitants of the oils that also can be rusted. The whatever the metal part or in the whatever the rust particle from the other part of the metals that also can be avoided from entering to the pump. The removable covers for easy access to clean all the dust or individual particles. Okay. Now, submerging the strainer can be incorporated with the pump inlets to prevent the all dust, sludge, and rust, etc. in entering to the pump. Removal covers for easy access to clean out all the residues and rust that may be accumulated. For removal covers, if it is there, it can be removed from that and it can be opened. So, a drain plugs to drain the fluid that contained in the reservoir. To drain that, we have to take the drain plugs, and magnetic tank drainers also there. It is attracted to the holding whatever the ferrous or iron particles which is there. That magnetic cleaners will be there. It can be removed with the help of without inserting into the like cotton or something. It may damage to the thing because all will be polluted. So this type of magnetic cleaners will be taken better than that. Heaters are essential for the reservoirs in the cold weathers. Sometimes the cold, because of the coldness, the viscosity of the oil become very thick. That time some of the heaters, like some of the cold inside the submarines, or sometimes which will be going for the hilly areas, there we have to work for the vehicles or movable things. Sometimes because of the weather conditions, some heaters also can be used for the cold weather. So the sizing of the reservoirs must be properly sized so that it can supply sufficient quantity of
PPT is not visible.
PPT is not shared, ma'am.
Is it clear, sir? Now is it
Yes, ma'am.
visible?
Now it is clear.
Okay, 1 minute. Just I'll show this one. This is a magnetic tank cleaner. Can you see this one? This is the one which is used for cleaning purpose. And some heaters are there. We can use occasionally according to the cold weathers. So some heaters are necessary for this reservoir, because you know that whatever the viscosity has will make the viscosity of oils not to go more thicker. That's why we use the heater. The sizing of reservoirs must be properly sized so that it can be supply sufficient quantity of fluids to the system. It can be accumulated as the effect of thermal expansion of the fluid and changes in the fluid level due to the thermal or some normal conditions of operations. These are all, it should be having proper storages. It should be free from dust and other particles. It should be have a cooler to maintain the temperature, and it should also have an indicator, the level of indicators or temperature sensors, or it should also have some of the cleaning the suction different type of filters also, so that everything it should accommodate in that same unit. It can be ensured the fluid in the circulating has a reasonable dwelling time in the reservoir to allow the fluid to cool and suppress any type of turbulence. So whatever we will be having in that time, whatever the circulation time it is there, whenever the pipeline is having in the working condition, that time it should ensure that all the parts of the things, like whatever the containers it is having, everything should be in the good condition, so that it will be, we have to make sure that a reservoir size, sometimes it is depending upon the manufacturer, reservoir size that is 3 into 5 into pump rate, whatever the flow rate is there, that is meter cube by minute, or it is in the gallons, or it may be standardly we go for the hydraulic reservoirs ranging from 1 liter to 60 liters. So this is my standard of Indian standards. It goes with the 1 liter to 60 liters of reservoirs will be there. As the moving vehicles are there, it can be reduced according to the size of the automobiles. So next we'll be showing some of the sections of this. So mounting plates will be there, and also an additional side gauges, additional filters and breathers, installed couplings, aluminium endovers or bin type of endeavors, the contaminated things are there for to tray or stands. This is the one which goes for the. Yes, I downloaded from some thing. The figures are not so clear, but you can see the cut section. Can you see the wording? Alphabets is clear or what? You just minimize in your system, and you can see that there should be a. According to this, everything sometimes if I go for the with the manufacturer, some of the things will be missing, but most of the essential things are should be there to safeguard and to take care whatever the maintenance work of the hydraulics. So this is the cut section of the thing. Probably it looks like this. Standard one, it looks like this. It's a enclosed. The size of the accumulator or whatever the things are there, tank, whether it is a L shape or it is a square shape, this is the one which is available in the market. So this serves for the reservoir, which will be oil will be preserved for our working purposes. So is it clear? Any doubts? Any doubts?
No, ma'am.
Okay. Shall we continue or shall we stop the class? Shall I continue or shall I stop the class? Can we start with the Friday?
Yes, ma'am.
Okay. Is it clear today?
Yes, ma'am.
Okay, one more thing I wanted to ask you. I am in the WhatsApp. You can take that number. You can call it anytime. And if you have any issues with our drives or anything, you can call me back. I will come back to you. Okay. And happy festival. Tomorrow, all of you happy actually for the.
Same to you.
Thank you, ma'am.
Okay, ma'am. Thank you very much. Okay.
Thank you, ma'am.
I say as much as maximum, I'll send you the material. I will take care that it should be reached. And tomorrow you go through that, then you can come back with the Friday. Thank you much. Shall I end the class?
Yes, ma'am.
Thank you very much. Okay. Happy festival, happy Pongal, happy Makar Sankranti.
Same to you, ma'am. Everything.
Okay, ma'am. Thank you. Bye bye.
Ma'am,
Yes, Sai Kumar, tell me, ma.
ma'am, when I am executing this file, actually I tried one simulation right now.
Okay.
When I executed and I started pushing push button, everything was gone well, and automatically it was the tab got closed.
Tab is closed.
Ma'am, can you show me the procedure once again? I will see what mistake I am doing.
Sai Kumar, first I will check that folder with is corrupted or what. I'll just go and see. Something it will maybe there. I will take it from my hard disk. I'll send you again to you personally. Okay? Then you
No,
work
ma'am.
out.
No, ma'am, it is not required. I think it is downloaded and it was when I started a simulation, 2 by 2 wall I had taken and I have executed. But I want to know the process once again, where I am doing wrong.
Okay, okay. Hmm. In the meeting, correct?
On desktop, there is an Ongc online Hyderabad folder.
1 minute, sir. 1 minute.
Open. No, not in this. Yeah. You opened hydraulics or pneumatics, ma?
FSP3 demo. FSP3 demo. Open, sir.
After
You
that,
have
you
opened
need to go to
FSH3.
Okay, go back.
FSP3 demo in bin.
Wait. Just FS. This one, na?
FSP3 demo in bin. I have to go in bin.
Okay, shall I share the thing? Whatever I'm going?
shared already.
1 minute, I will just observe the thing, ma. See, first you go FSP3 demo, double click, go to bin.
Yes, ma'am.
Then here you can see FSP demo.
Yes.
Now you go here, just go for file. Okay, new page will be created.
Yes, ma'am.
Okay, click anything, compressor, that is my source, click and drag.
Yes, ma'am.
Okay, then I double acting cylinder.
Yes, ma'am.
Okay, then I will take a 5x2 or 4x2 wall.
Yes, ma'am.
Then after making that gray color, you right click.
Properties.
Please go for animations. That is my left actuation or thing. So I will go for here manual spring return.
Yes, ma'am.
Okay. After here I will connect that hose pipes. Okay. Pump or compressor. Go for 3, right click, go for properties. Then you go here, confirm the number and exhaust. Okay,
Yes,
here.
ma'am. Yes, ma'am. Yes.
In the taskbar, you go here like a triangular start.
Yes, ma'am.
Okay, click on that live light. It is coming.
Yes, ma'am.
Okay, then go and press this lever or push button. Working?
Yes. Exactly at this point, what happened is my folder was automatically closed. This page
Okay.
is closed.
Okay, now it is same thing is Happening now also?
Happened, ma'am. Just I also did what you did.
Okay. It means actually I think that I will check once again with the Joji sir whether it is in the demo version, whether we should copy from original and then we have to send, I think. I will check, ma. I will check what is the issue. I will check.
Ma'am, can I share my desktop and I will show it to you? Is it okay?
Share it, ma.
You
Share
can,
it.
1 minute, we'll make you co-host so that you can share your screen. Okay?
We'll make
Okay,
you
ma'am.
co-host, then you can share.
Okay, ma'am. Okay.
Yes, sir, we have given you the co-host thing. You can share us your screen now.
Okay, I'm sharing my screen. This is the FSP3 demo, right, ma'am?
Yes, ma.
I clicked on it. This is the. Are you getting the screen or not, ma'am?
Yeah,
Yes,
we can see
yes,
you.
correct.
We can see, sir.
Yes, sir.
In file, I'm opening a new page.
Why this picking has come here?
What,
Why
ma'am?
this type of? Why this?
That he has selected now.
Okay,
No,
okay,
please
do
go
it.
ahead, sir.
Go ahead, sir.
Compressor. Double acting cylinder.
Sir, can you please share your screen, like the whole screen, because we can only see your previous folder. That's all.
Acha,
Uh,
where it was gone.
you need to stop the screen share and then share the whole screen.
Okay, okay.
Yeah.
You can share what have to share from here.
Sir, once you click the share option, no, sir, then you see the first option. It says screen 1. Can you see screen 1 once
Yes,
you click
yes,
it?
ma'am.
Yeah, please do that, sir.
Okay, I'm sharing it.
Yeah, now it's quite clear. Yeah, we can see it now.
Okay, from ma'am ONGC Online Hyderabad, I go through FSP3 demo,
Okay.
bin,
Yeah,
FSP
correct.
demo. Yes, ma'am.
Okay, ma. Okay.
I already placed the double acting cylinder. I placed a compressor. I'm placing a 4x2 all over here.
Okay.
I'm connecting these two lines.
Okay. Okay. Go for properties. Very good. Very good. Very good. Go for exhaust. Okay. Now select this. Yeah. Okay. Manual. Okay.
Okay, ma'am.
Okay, ma.
I think everything was clear, and right now I'm executing
Wait.
this.
So now you just come out and click again. Screen. It should not be gray, ma. It should not gray.
Okay.
Now you give simulation.
Simulation.
Yeah. Press it.
Start.
Now live came.
I'm clicking on it. Just to focus on this, ma'am. It will automatically getting closed. Right now, the system will close automatically. Just I'm clicking on. It was closed.
Yeah.
Okay.
You
Okay,
observed it,
ma'am.
ma'am?
Yeah.
We got through the issue, sir.
Yeah.
We'll send you the file once more, and if the same thing continues, then probably it's some issue with your laptop, I believe. Because we are using the same thing. We are using Windows 8, and it's worked fine for us. That's why.
Okay.
Sir, Windows 7, you have any desktop or any other laptops?
I'm using Windows 10, ma'am.
No. In your house or your friends, you are having a laptop or desktop which working on the Windows 8 and Windows 7?
No, ma'am. No.
You just try, sir. Tomorrow you try your neighbors or somebody. You just work on that.
No, because the problem is the software, the version which we have, it works for most compatible with Windows 8 and 7 only. So it will be better if you go for these two OSs only, sir. Or else maybe we'll have to look for the OS which supports for Windows 10 as well. So we'll give us a day's time. We'll get back to you on.
Sir, actually, what is happening here? I'll tell you the thing. Problem I understood. Actually, what happened when PLC and this I purchased, Windows 7 was supporting. As soon as Windows 7 went, Windows 8, it was not upgrading. So I went and purchased again Windows 7 for the systems. Like this for PLC and this say Siemens, and they have a particular OS. Okay, I will find out from Joji sir, and I'll give a thing. I'll give a good whatever the working condition thing you can work out, sir. Okay, sir.
Like,
Give me
ma'am, is there like any permission has to be given or what? Actually, what I did is like I downloaded this folder and extracted all the zip files from it and I saved it in my desktop.
Okay.
So after this only, actually I am able to simulate these things. And after simulation, it was automatically getting closed. I think it is due to incompatible to in Windows 10 or it is only
The OS is the issue, sir.
OS issue, sir.
okay.
Okay. Otherwise, just try for some other PCs or some laptops which is having old laptops.
Maybe in your office, if you go to NGC once, maybe the desktops which are there in the office, they're working at the old OSs and all. So maybe if you can try it there once, it will be better, I think.
Acha, means it is not compatible for the new Windows system, right?
Yes, sir. They don't actually let you update the software that frequently.
Yes. Actually, when I'm downloading this folder, it is not allowing me to download this. I actually gave permission to my PC and I what
Yeah, understood, sir. I got your point. Got your point, sir. Yeah. We understood, sir.
No problem, sir. We'll see what is the best we can do. I'll ask the we have a very good relation with Festo. I'll ask the anything demo they have which works on the Windows 10.
No, ma'am, don't call me as sir. Please call me Sai Kumar.
Okay. I'll try, ma. I'll try and I'll come back to you.
No issue, ma'am. Actually, I want to show you what happening. That's what I showed you.
Good that you showed us. Now we know the problem.
Now we know the problem, sir.
Okay, ma'am. Thank you so much. Actually, I did a simulation in front of you. I'm happy.
Okay. Good. Bye. Shall I end the class?
Yes, ma'am. Yes, ma'am.
Thank you, sir. Thank you. Bye.
Thank you.
Bye.
Well done. Okay, bye.